Hello, good morning. Any questions if you have from previous classes? Any doubts from previous classes? Sorry? Give me full form. Who is doing this? Docking experiment often is done. Think of, the question is about SPEDX. Docking experiments are done to ensure that can you match up to already existing object in space, and then can you like park your smaller probe into a larger probe. ऐसे समझ लो, जैसे अब गाड़ी आपको पार्क करना है, there is a place आपको गाड़ी पार्क करना है. You have to know about direction, कैसे रिवर्स करना है, सब कुछ, right? So similarly, let's say for example you have International Space Station. International Space Station वो platform है where human beings can go and stay there for very long. There is a capsule here carrying astronauts to the space, but that capsule has to park itself. It has to attach itself to the existing International Space Station. Sorry? For a lot of just astronauts तो ऐसा है नहीं ना कि वहीं पे जो astronauts वहीं पे हैं. They come back, new astronauts go there. So whenever they go, they attach themselves to some infrastructure which is already part of the space station. But to do that, think about how difficult that must be. That you have to match up to the speed of International Space Station so that you have almost zero, not almost, zero velocity with respect to the International Space Station. And then you go and park yourself, like you go literally and dock yourself. That is called docking. So docking is often used to have control of over your vehicle in low Earth orbit. I will have to read more about it. SpaceX, what ISRO has, like this is what docking is, but what ISRO has been able to achieve, I will have to read more about it. हाँ, so yeah, भारतीय अंतरिक्ष स्टेशन जब बनेगा 2035 में जो हमारा प्लान है, that by 2035 we want to have a space station, then that docking will be important because essentially it will mean that we have a permanent platform in this space and astronauts go there, stay there for some time and come back. So for that, this docking experiment will be very, very important. I will talk about that in today's class. Yeah. In last class, I was talking about supercomputers. I was talking about certain problems which cannot be solved by our day-to-day life computers. Problems which are very complex, problems which depend upon many variables, and even a small change in any of the variable, your outcome becomes very, very different. And because of that, you cannot rely upon for such problems on our day-to-day computers. They are not capable enough to solve such problems. So what are some of the problems? The most simplest and the most obvious problem I can talk about is weather prediction and climate modeling. That think about Indian Meteorological Department, IMD. IMD works under Ministry of Earth Sciences. Think of weather prediction. Weather prediction जब भी IMD करेगी आने वाले 2, 3, 4, 5 दिन का करेगी. इससे ज़्यादा अगर करेगी, there will be lot of error. So whatever the prediction will be for tomorrow, that will be much, much more accurate compared to day after tomorrow or compared to 2 days after today. So weather is a very complex phenomena. It depends upon so many parameters. Right? Think of right now how we predict weather. Indian Meteorological Department has lot of stations on the ground. Those stations are collecting data about moisture, about pressure, about air movement. Then they have lot of balloons flying in the stratosphere. Then they have aeroplanes as they fly in the upper part of troposphere and stratosphere. They collect lot of data about air pressure and moisture, etc. And they send that data to IMD stations. And all of that data has to be analyzed. So for example, think about we have to predict weather of Delhi. And weather of Delhi not just depends upon what is happening in Delhi or the parameters which are only and only present in Delhi, but also something which is happening outside Delhi, or maybe something happening which is few hundred kilometers away from Delhi, and that will have some impact on Delhi 2 or 3 days later. So weather is a complex phenomena. It depends upon so many parameters. There are so many inputs. Even if you take one input wrong or you do not account for one input, your output becomes entirely different. But to account for all of those inputs together and accurately predict how weather is going to evolve, that requires powerful supercomputers. जितना powerful supercomputer होगा, weather prediction उतना better होगा. Now, if weather is complex, climate is even more complex. आपकी geography की class तो नहीं हुई है अभी? So let me try to explain the difference between weather and climate. Often we use these two words interchangeably, but they are very different. So climate can be thought of as an average of weather. जैसे, I do not know what will be the weather 1 year from now, from today, right? जो भी date है आज. But I do know that in month of May, the temperature, the average temperature will be very high. It will be summer season. So when we look at the general trend in weather for, let's say, a larger time duration, we use the word climate for it. But जो day to day life changes हैं, जैसे दिल्ली में भी 2-3 दिन पहले बारिश हो गई, आंधी आ गया, those day to day changes which occur, that is called weather. So suddenly rainfall, heat wave, storm, all of those things which occur on a day to day basis, that is weather. But take all of that average of a larger duration for a month, for 2 months, for 3 months, for 4 months, and that becomes climate. So predicting climate is even more complex. And by the way, when we do climate prediction, then we often try to think of how things are going to evolve 10 years down the line, 50 years down the line. Now we can do that. In weather we cannot do that. जैसे हम ये नहीं बता सकते कि आज से 10 साल बाद, आज के दिन 10 साल बाद exactly क्या weather होगा. We can never do that. ये possibility ही नहीं है. Earth is such a complex system. But on an average we can say that will the, अभी जो मान लो average temperature दिल्ली में 40-42 degree Celsius है, will we be able to say that 10 years down the line it will become 42.5 or 43? That we can do. So we can talk about climate. So this is called climate modeling. But don't for a moment think that climate modeling is also easy. Climate modeling is very, very difficult. Right? Just one of the reasons why so many people might think that climate change is a myth. ये पढ़ा होगा ना आपने? So global warming, climate change deniers and people who deny that climate change is real. And one of the arguments they make here is that climate is such a complex system, you cannot predict how things are going to evolve. That's a separate issue, I will not go into that. But we can do that. We can do climate modeling, and we can predict how climate is going to evolve 10 years or 15 years down the line. And again, even for that, we require very powerful supercomputers. So supercomputers are very important for even things like weather prediction. But think about more problems, like some more interesting problems. That आप कोई river है, that river is connecting 2 cities. आपने उन दोनों city को connect करने के लिए एक बड़ा सा bridge बनाया है. You have made a suspension bridge. That bridge, of course, is going to become very active with so many vehicles. But you do a simulation that how much weight this bridge can sustain. Under what circumstances that bridge is going to collapse. You try to understand. So you make a model of that bridge on a supercomputer. And then you make changes. That is what simulation is. I have used this word simulation a lot. So simulation is to understand how a system will evolve given the all inputs you already have. जैसे I have done here is, I am trying to simulate how this bridge, larger bridge connecting 2 cities across a river, how it is going to behave, let's say, when there are 100 cars. How it is going to behave when there are 1,000 cars. How it is going to behave when there are 2,000 cars. How it is going to behave that suddenly on one side of the road you have only heavy vehicles and on the other side of the road you only have lighter vehicles. What type of changes are going to occur? So rather than actually making a bridge, doing that, we actually do a computer simulation for that, and we try to understand how things will evolve so that we can plan accordingly. We can make changes accordingly. So whenever we have to, again, this is a very good example of simulation where we are trying to understand how a large structure will evolve or will behave under different input. We cannot do that on this computer. We will require very powerful computers for that. Same thing is also true for even space launches. That in the previous topic हमने discuss किया था, we ignored lot of other parameters. When we launched a satellite, we launched a rocket, talked about launching a rocket. We did not talk about what will be the impact of air, what will be the impact of perhaps other celestial object. Chandrayaan 3 हमने launch करा. Like we kept raising the orbit of Chandrayaan 3 at a point where now we can allow it to insert into a lunar orbit. but ये सारी चीजें हम कर सकते हैं पहले से, because we have powerful computers, supercomputers, which can simulate all of that. And accordingly, we can program our Chandrayaan 3 lander and rover that at what point, what type of instructions need to be given. You read the news that there is a cyclonic wind developing in Bay of Bengal. But then you also read the news that this cyclone, which is evolving, how powerful it is, you already have this information. How it is going to move, when is it exactly going to actually land on the coastal part, in Odisha, in West Bengal, wherever it is. And how much damage it can cause. That will be important part of disaster management. But we can do that because we have, first of all, we do collect a lot of data about with help of remote sensing satellites. And then that data needs to be analyzed. It needs to be made sense that what type of wind system we are talking about. And we do that with help of supercomputers, right? So supercomputers are being used in so many different areas. AI is using, there is a question that does AI use supercomputing technology? Yes, it does. All of the modern AI, they are dependent upon parallel processing. I will talk about AI in great detail, don't worry. But the answer is yes. Even in artificial intelligence, we do use aspects of supercomputing. In medicine discovery, that how molecular interactions occur. जैसे body tissues के साथ, जो हमारे body tissues हैं, these are biomolecules. Medicines हैं, these are molecules, synthetic molecules. How these molecules will interact. We try to simulate that with help of supercomputers. And then we try to understand if a medicine will be good or not good. So even for discovery of a medicine, we use supercomputers. So in so many areas, we actually use supercomputers. In big data analytics, we use supercomputer. Let me talk about that also. Big data analytics. So data analytics is not a new thing. That should be very clear. Data analysis is simply you have some data, you're trying to make sense of it. जैसे मैंने अभी कुछ दिन पहले एक स्पेस टेक्नोलॉजी का क्विज किया था, अगले क्लास में हम तीनों टॉपिक का एक साथ एक और क्विज करेंगे. So that is an announcement here. But so अभी हमने क्विज करा था. I looked at the data of your marks. I am looking at that in few questions many of you got wrong. Maybe there is some conceptual clarity here. So I'm trying to make sense of data, looking at how you have done in different question or what has been the average marks. That is data analysis. Data analysis, people have done it like even before all the modern economic development, people have done data analysis. But big data analytics is where we try to make sense of huge data sets which prima facie do not even look like that they will have some correlation, but turns out that they are correlated. Turns out that what you eat may have some impact on what is your political ideology. It's a random suggestion, but things like that. That data sets which are not even like, prima facie does not make sense. But there are computers, there are supercomputers who try to make such correlations of some patterns that based on the books you read, which party you are going to support. Things like that. So, and yes, we can do that. So think of जो YouTube आपको next video recommend करता है. And you'll always feel that this next recommendation is to the point. Like you actually do want to watch that next video. Now, how can it do that? So clearly it has not just your history, but it has history of all of its users. And based on all of the history of all of the users, it knows the preference of same type of user. So you are not the only one who on late night 10 listening to Jagjit Singh. There are so many other people who do the same thing, or Arjit Singh for that matter, right? So a lot of people do that. Based on time of the day, based on perhaps what type of user you are, what type of videos you watch. So it's not just you. YouTube or Google will try to profile you, that what is your profile, in which criteria you fill. And then based on that, and based on what you have watched in the past and other people who have similar taste as you, what they have watched in the past, and based on that, it is going to recommend that next video. So again, that is a very complex data analysis. But ये तो चलो फिर भी सिर्फ और सिर्फ YouTube video data analysis है. But big data analytics can include a lot of things, different data sets which are not related. I remember one of the suggestions made by one of the economic surveys, that how big data analytics can be used in governance, in public service delivery. गवर्नमेंट ऑफ, जैसे इंडिया में एक बहुत बड़ा चैलेंज ये है दैट जो बेनिफिशियरीज हैं हम उनको सही से आइडेंटिफाई नहीं करते. जिन लोगों के पास एक्चुअली पैसा जाना चाहिए, people who should actually get government services, they do not get that. And people who should not, they do get government services. And economic survey was making a suggestion that how we can use big data analytics. For example, I remember that suggestion, and I still remember that because I could relate to it. So it was making a suggestion that think about if somebody has a four-wheeler vehicle. Somebody bought a four-wheeler vehicle. Whenever you buy that, you have to pay a lot of taxes, you have to do insurance, road tax, all of those things. All of that data is available to some ministry, right? Ministry of National Highways, or maybe Ministry of Finance. And then look at another data below poverty line. That people who are below poverty line, that data is also maintained by some ministry. In rural areas, we do find many cases where people who have like few four-wheeler vehicles, they are the richest people of the village, but they are also the closest to Mukhia, or they themselves are Mukhia. And because of that, they will also have their name in below poverty line, or some family member will have name in below poverty line. So the survey was making a suggestion that we can find this simple correlation that somebody who does have a four-wheeler ideally should not be in below poverty line, somebody who owns a vehicle like that. So two data sets lying silos with respect to each other, lying in silos with respect to each other, no interconnection. But what if we make those interconnections, those correlations, and we will be able to identify beneficiaries in a better way. But again, to do that, to analyze such data for so many millions of Indians, we will require supercomputers. It cannot be done by normal computers. So supercomputers can have applications in many, many areas. And जितने भी powerful nations हैं, जैसे in national security, अमेरिका में 9/11 के बाद कोई terrorist attack नहीं हुआ है. 9/11 happened, but after 9/11 there has not been a single terrorist attack in America. Because they invested in very, very powerful supercomputers. जो National Security Agency है अमेरिका की, they have invested in powerful supercomputers, and they monitor the chit chat which is happening in America, but it is also happening in global scale. They have one of the biggest spy network, and they have some of the biggest powerful supercomputers. And those supercomputers are equipped to predict any type of national security threat beforehand, and they can neutralize, they will be able to neutralize that. So even India does that. So जो हमारी intelligence agencies हैं, they also do the same thing. But जो capability अमेरिका के पास है वो बहुत ज़्यादा है. And fundamentally it is because of the fact that they have more powerful supercomputers. The most powerful supercomputer of the world is a computer called Frontier. Frontier belongs to National Security Agency of America. It has capability of more than 1000 petaflop. The only supercomputer which has capability in 4 digits of petaflop. Compared to that, the second most powerful supercomputer belongs to Japan, a supercomputer called Fugaku, which has capacity of somewhere around 450 petaflop. In India, the most powerful supercomputer is Airavat or Param Siddhi. So Airavat has capacity of, Airavat has been designed for AI. So if you use it for AI, then it has capacity of about 30 petaflop. But in general, if you use it for general purposes, then its capacity will be 6-7 petaflop, compared to like few thousand in case of America. So that tells you the type of differences I'm talking about. Supercomputers are quite good at so many things, and they have applications in many areas. You can write down few things. Application of supercomputers. Application of supercomputers. Write down. First, in scientific research. In scientific research. In scientific research. For example, climate modeling. Climate modeling to predict changes over time. Changes over time. molecular simulations. No, Airavat and Param Siddhi are not same, they are different. Molecular simulations, which has applications in computational biology, which has applications in computational biology, computational biology. This can help in, write down, this can help in drug discovery, protein folding simulations, Let me explain this. Protein folding simulation. The most important biomolecule in our body is DNA. I'm very sure that all of you are aware about that. The सबसे important biomolecule हमारे body का वो DNA है. DNA is the information genetic carrier of our genetic information, right? Information which it has taken from our parents, right? So DNA is the most important biomolecule. What it does? The first thing it does, of course, is that it carries genetic information with it. And I will be able to pass that information to my offsprings. You will be able to do that your offsprings. So it carries that genetic information generation by generation. But what it does within my body, like what it does, what purpose does it serve? Of course, the most important purpose here is that all of the properties which you can see, like even color of my eyes or the aptitude I have, lot of that can be attributed to the DNA structure. But one of the most important thing it does, that it is helpful in producing the second most important biomolecule, which is called protein. So jitne bhi biomolecules hain, we can divide them into 4 parts. We have carbohydrates, immediate source of energy जो है वो carbohydrate है, lipids, energy which is stored for longer term, fat जैसे एक बहुत बड़े example जो lipid का है वो fat है. But lipids also play some other role. Lipids are part of your cellular membrane, which does not allow everything to enter inside your cell. So lipids are very important biomolecule, but proteins are again very, very important biomolecules. Protein do most of the things in our body. That you have eaten something bad, body needs to secrete some specific enzymes to digest it. That is done by some specific protein. You're feeling very happy, some hormones are released. Those hormones are, there is a very good chance they are proteins. Right? You have been infected by some disease, some pathogen, body is producing antibody. That antibody is protein. So our body knows, it's like a very sophisticated, powerful machine which knows how to make thousands of types of proteins. Thousands of types of. And all of that information, that how protein has to be made, that is encoded in our DNA molecule. So DNA molecule का जो सबसे important part है वो है protein synthesis में. अब वो process खुद में एक बहुत interesting process है. I do not want to go into that. My main concern here is that जितने भी protein molecules and there are thousands of protein molecules. Protein molecules are very complex. In complexity, they can be even more complex than DNA molecule, which in itself is a very complex molecule. But जितने भी complex protein molecule हैं, they are made of just 20 other molecules. What are those 20 molecules? Amino acids. There is a type of molecule called amino acid. Amino acid is essential part of protein. And in nature, we find only 20 amino acid. 11 of them are found in our body naturally. 9 of them, they are not found naturally. We have to eat food to fulfill for those other 9 amino acids. For example, we can fulfill that even from plants, often from animals. So our bodies, when you eat protein from outside, our body knows how to recover amino acid out of that protein. And then with that amino acid, it can make a new protein. So there are only 20 amino acids. And those 20 amino acids in different form come together, not necessarily all 20 of them, maybe 2 or 3 of them also, but they come into some sort of a pearl like, ऐसे समझ लो कि एक necklace है, necklace के pearls हैं. So those amino acids first arrange themselves into a very nice pearl form, forming a necklace. But that is not the final structure of protein. Once you have this necklace now takes a 3D fold. It folds itself into 3 dimension. And that is the final structure of protein. This is one of the most difficult problems in all of the science we know of, including even understanding black holes or quantum gravity. It's like as difficult as solving those problems. That you have been given structure of amino acid, आपको दे रखा है, and you have to predict that what will be the final structure of the protein. ये जो protein folding है, that आपको amino acid का जो exact chain क्या है वो आपको दे दिया. आप initial problem I started with, I'm not even telling you that which amino acid, what type of chain. I'm actually giving you that what that chain is. You just have to tell me that how this chain is going to fold itself into 3 dimension, and you have to predict what is the protein structure. This is one of the most complex problem. This problem is becoming more and more easier now because of advancements in supercomputing, particularly because of advancements in artificial intelligence. There are AI tools which are able to predict this problem really, really well. And this is significant. Why this is significant? Because if we can predict protein structure in a lab on computer, then we can literally make those proteins into lab. Proteins which are made into our body right now, we can make those proteins into lab. We can make antibodies into our lab. We can make lot of other type of proteins into our lab. Again, this is a distant dream. ये अभी हम आसपास भी नहीं है इस capability को achieve करने के लिए. That आपने step by step अपने constituents लिए और उसको use करके आपने एक final protein बना लिया. So we are nowhere near that. But the first step in coming near to this dream will be solving protein folding problem. That let's solve protein, how it folds itself into 3 dimension. And for that folding, so this branch of computer science, so when we use computer science into biology, that interdisciplinary branch is called computational biology. So biology is not a very difficult subject when you study in, let's say, class 11th or 12th also. It becomes very difficult when you start studying about genetics, and suddenly you realize that this is a very, very complex topic. So computational biology applies postulates of or understanding of computer science or computer science in solving biological problems. One of that more complex problem is protein folding. And that protein folding problem is becoming easier and easier with help of supercomputers and artificial intelligence. Next, in astrophysics, in astrophysics, to understand evolution of solar system or even universe, evolution of solar system or even universe, जैसे we try to understand that what happened after Big Bang. Big Bang happened. We do not know why it happened, but we know that it happened. Big Bang happened. After that, universe went through many phases, some major phases. Even before all of the data which was collected by telescopes, we were able to predict few things accurately. That is because of supercomputers. Similarly, how solar system was formed. Like why Mars and Jupiter के बीच में इतना distance है. All of those things we have good answer to. And because of computer simulations we have done with help of supercomputers. So we can simulate things and we can understand how things might have occurred, even though we have no way of knowing, going back in time, how it actually did occur. But we can come very close to it. I will not say that we can do that with 100% accuracy, but we can come very close to it, that how things must have evolved when solar system was formed. And we can do that because of supercomputers. So all sort of simulations. So this is a simulation which already has happened in the past, but even simulations which can predict few things about future, for example, how a cyclone is going to move. So next you can write down in disaster management. In disaster management, disaster management, predicting extreme weather events, predicting extreme weather events, extreme weather events such as storm surges, cyclones, such as storm surges, cyclones, etc. Next, in national security, in national security, in national security, इसमें बस एक लाइन लिख लेना, monitoring activity online, monitoring activity online, activities online to predict any type of national security threat. Predict any type of national security threat. Next, big data analytics, big data analytics, analyzing massive data sets, analyzing massive data sets to extract useful information and patterns. To extract, analyzing massive data sets to extract useful information and patterns. I can write down many more things. Like in multiple areas we can have applications of supercomputer. This is not an exhaustive list at all. We can add many more things where supercomputers are used or can be used. The last part of the discussion is give the setting supercomputing in India. Supercomputing in India. When Rajiv Gandhi was Prime Minister, India had requested America to import a supercomputer. But there was some embargo going on, trade embargo going on, and that request was denied. So need was felt that we should make our own supercomputer. The very first supercomputer we built, that occurred in 1991. Before that, some companies had privately bought supercomputers. Just I came across a very interesting news about Asian Paints. Asian Paint बहुत बड़ी company है, paint बनाती है, right? I came across a very interesting news about Asian Paint that in 1980s itself, they bought a high performance computing infrastructure from America, and they used that. So they did their own market research. They used that to predict demand in many parts of the country. तो उन्होंने पूरा supply chain अपने control में कर लिया. That rather than relying upon middlemen, they took everything in their own control. So Asian Paint is very famous for one thing, that if you go to a nearby store and you want a specific brand of Asian Paint, there will be stock available. But that stock will also not be unnecessary. ऐसा नहीं कि वो stock वो पड़े रहेगा 6 महीने तक और कोई नहीं खरीदेगा. So they are really good at predicting that in a specific geographical area, for a specific brand, what should be the demand here. And accordingly they supply that stock beforehand. So such type of problems are called optimization problems. जैसे even Amazon does that. जैसे आप Amazon पे आपने खरीदा कुछ और तब भी Amazon ने आपको बता दिया कि 2 दिन में डिलीवर हो जाएगा आपका ये, या 3 दिन में डिलीवर हो जाएगा, और हो भी जाएगा. 99% केसेस में 2 दिन में डिलीवर हो जाएगा. So clearly they have all this data about all of the warehouses they have. They have data about all of the logistic partners they have. All of the people who do delivery, all of that data they have. Where are you located? Where is the warehouse located? जहाँ से भी ये सामान आना है. कौन से routes हैं जिसके through ये आ सकता है? How much time it can take? All of that, they can do that for each and every of their consumer, because they do have very, very powerful supercomputers. The moment they start making lot of error. that उन्होंने 2 दिन में promise किया 5 दिन में आ रहा है. You will tolerate it for a day, for 2 days, but after that you will shift to Flipkart. That I'm going to buy from Flipkart now. So they cannot afford to do that. All the e-commerce giants, they cannot afford to do that. Whatever they have promised, they have to deliver. And now they can deliver because they do have powerful supercomputers which can forecast all of those things beforehand. So it's also good for companies. So some private companies already had supercomputing facilities in India. I also came across a news that IIT Kanpur had a supercomputing facility before Government of India had. That was some technology share between US and India. But the first supercomputer we built at the level of government, that was called Param. Param means super. Param 8000 in 1991. And there is an organization in India called CDAC, Center for Development and Advanced Computing. It works under Ministry of Electronics and IT. And उसका जो बहुत important part ही यही है, जो objective यही है, that how to invest into high performance computing facilities all across the country. Many more supercomputers were built. 2 supercomputers we should know, which are old but still active and still doing their job with high efficiency. Pratyush and Meher, they both are part of IMD and they are used for weather prediction and climate modeling. But then we should know about National Supercomputing Mission 2015. That is a very important topic for prelims or mains examination. So पहले तो आप इतना लिख लो. The first supercomputer supercomputer was Param 8000, built in 1991. Param 8000, built in 1991 by CDAC. Center for Development of Advanced Computing. Center for Development of Advanced Computing. Write down next point. Pratyush and Meher are 2 powerful supercomputers. Pratyush and Meher are 2 powerful supercomputers. प्रत्युष तो बहुत कॉमन नेम है. Pratyush and Meher are 2 powerful supercomputers used for weather prediction and climate modeling. Give this heading, National Supercomputing Mission 2015. National Supercomputing Mission. (2015). Write down few things here. It is an ambitious initiative. With objective of more than 70 supercomputing facilities across country. More than 70 supercomputing facilities across our country. In topmost technical and R&D institutions. topmost technical and R&D institutions are research and development, R&D, research and development institutions, topmost technical and research and development institutions. It is being implemented in phased manner. It is being implemented in phased manner. With focus on indigenization. Focus on indigenization. Indigenization का क्या मीनिंग होगा? In India, not relying upon other nations, in India. So, जो पहला phase है इसका, for example, हमारे पास again we do not have lot of capability in terms of even hardware, even in assembly. So the first phase was that even if we are buying parts from outside, the final assembly of the supercomputer, that will happen in India. Second phase, that may be some essential part we will be able to make in India. And finally, at the end of the mission, we should be able to make a supercomputer starting from like zero. And we can make the entire supercomputer with almost no help from any other nation, including both software and hardware. So the goal here is that in phased approach, we aim to increase indigenization. Initial phase, only and only assembly, but finally, all of the part made into India. Right, on this mission is implemented by, this mission is being implemented by Department of Science and Technology, Department of Science and Technology, and Department of Electronics and IT, Department of Science and Technology, and Department of Electronics and IT. So two different ministries. This is under Ministry of Science and Technology. This is Ministry of Electronics and IT. So it is a joint mission of two ministries, Department of Science and Technology, Department of Electronics and IT, via CDAC and Indian Institute of Science, Bengaluru, via CDAC and Indian Institute of Science, Bengaluru. Indigenization means that we want to make something in India rather than importing things. जैसे अभी तक क्या है कि electronics जो पूरा का electronic sector है, we often rely a lot upon import. Like literally in Hindi it means Swadeshikaran, that we want to make things in India for India's specific requirements rather than relying upon import from other nations. So growing indigenization means that maybe not everything will be indigenous in initial phases of this mission, but as we go into finally completion of the mission, the indigenization percentage should keep on increasing. That more and more parts we should be able to make in India, and of course assembly should occur in India itself. We do that. We do use supercomputers in cybersecurity, without a doubt. So, lot of breaking encryptions, we use supercomputers for that. To take care of attacks, we use supercomputers. Hackers ने किसी system को hack कर रखा है, using some sort of encryption key, and to decrypt, we use supercomputers. So we already do that. So in cybersecurity, we do use supercomputers. One more point you can add here is, the mission also aims at having skilled workforce with expertise in supercomputing. सुपर कंप्यूटर्स बनाने में, ऑपरेट करने में चैलेंजेस देखो बहुत सारे हैं. जो सबसे बड़ा चैलेंज है वो एनर्जी कंजम्पशन है. दैट अ सुपर कंप्यूटर ऑफ फ्यू पेटाफ्लॉप will consume as much as energy as a small town. So they are like, they guzzle lot of power. They use lot of water for cooling requirement. And remember, even this normal laptop, if it runs for very long, it is going to heat up. So supercomputer is going to produce lot of heat energy. And then it will not be good for the electronic circuitry. So wherever supercomputers will be kept, we also have to invest a lot into cooling requirement, that we need to ensure that room temperature does not increase a lot. Otherwise, your electronics is not going to function really well. And cooling requirement is not at all environment friendly. ये जो AC और ये जो fridge हम use करते हैं, it emits lot of greenhouse gases which contribute to global warming. तो हमने room में तो ठंडा कर रखा है, but the gases which are being pumped outside, they actually contribute to global warming. So cooling requirement is not at all good. So supercomputers in general are not considered very environment friendly because of how much power they consume or because of the cooling requirement. They also are very expensive to build, it goes without saying. They require high skilled workforce. Not that India has lack of it, the only problem is that people often go out India then in such cases. So brain drain is a huge issue for a nation like India, right? So all of these are problems which can be highlighted. Give the setting challenges. 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 Enormous power consumption. First, enormous power consumption. Enormous power consumption. Second, cooling requirements. Enormous power consumption. Second, cooling requirement. Both of these issues, both of these are not environment friendly. Are not environment friendly. I should add a line here that they're not environment friendly because अभी जो हमारा power consumption है, most of that comes from burning coal, and burning coal is not environment friendly at all. If we could, let's say for example, more renewable energy sources or nuclear energy for that matter, then it's not a huge challenge. Like in terms of greenhouse gases or air pollution, it's not a huge challenge. But the current जो हमारा energy basket है, that relies a lot upon burning coal, and because of that there are environmental problems. Similarly, if we can find suitable alternatives to all of the gases which we use right now, then also cooling requirement can be more environment friendly. But the current practices हैं, they do not make supercomputers environment friendly. Third, supercomputers are complex to operate and maintain. Are complex to operate and maintain. Requiring specialized knowledge and expertise. And last point you can add, they cost millions of dollars. They cost millions of dollars. So they're very expensive. They're very expensive. जितने भी powerful nations हैं, and जितने भी powerful tech giants हैं, Facebook, Amazon, Microsoft, Google, they all have invested millions of dollars into their supercomputing facilities. One last line you can add in next paragraph as a concluding remark, as a factual information. In India, the two most powerful supercomputers in India, the two most powerful supercomputers are Airavat and Param Siddhi. Param Siddhi. Built under National Supercomputing Mission. Built under National Supercomputing Mission. There are a few questions. Molecular simulations include genome sequencing. So yes, even for genome sequencing, we can use supercomputer. Just the Department of Biotechnology announced that they have completed genome sequencing of 10,000 Indians. And the data which is stored, that 10,000 genome data, it is stored in a supercomputing facility not located very far away from here. There is a facility in Faridabad, and that facility has a very powerful supercomputer where this data is being stored. So the answer is yes, even for genome sequencing, we do use supercomputer. How is AI different from supercomputer except handling large data? That's a good question. We will answer that when we will discuss artificial intelligence. Does amino acid, 20 amino acid also include BCAA? I do not know about that. Simulation means data is provided by humans. Not necessarily. We can just have sensors, and those sensors can collect data. But yes, we have made those devices, those sensors, and they are collecting data on our behalf. So it's not just data about humans, but it is also data about atmosphere, or so many different type of data which can be collected. Supercomputers are quite big reasons for technological unemployment in India. That's a complex question. We will try to answer that question again in AI. That artificial intelligence या जो high performance computing है, उसका impact on employment क्या होगा? ये हम discuss करेंगे AI as a topic में. Any other question if you have? The next topic which I'm going to discuss will be one of the most complex topic. Give this heading quantum technology. One of the most difficult also to comprehend. But before I start, I promise you that whatever we are going to discuss and whatever we are going to write, it will be more than enough for prelims or mains examination. But it will be a difficult topic to comprehend. So give this heading quantum technology. The reason I'm discussing this topic is this advancement which is happening in quantum technologies all across the world, but even in India. So last year, in 2022, and in fact in 2023 itself, Government of India announced a national mission on quantum technology with a budget of 8,000 crore rupees. We do not allocate such huge budget for science missions. So this will be one of the few missions where we have allocated such a huge budget for quantum technology. But what does this word mean, or what do we aim to achieve here in quantum technology? This is what I'm going to discuss. Before I jump into quantum technology, I should talk about that it is application of quantum mechanics. That remember in the very first class, again I told you that we try to understand how nature works. That is what science does, that we aim to know how nature functions. And with help of that understanding, we try to develop technologies. Quantum technology is based on a branch of physics called quantum mechanics. Quantum mechanics is not a very, it's not an intuitive concept to appreciate. जैसे Newton's laws of motion आपने पहली बार पढ़ा था. Even though even if maths was difficult, चलो ठीक है maths difficult है. चाहे gravity भी पढ़ा था आपने, उसका भी maths आगे level पे difficult हो जाता है. But it made sense that an object, even if I have to change the direction, I need a force. It made sense. You could actually feel it. You could witness things with your own eyes, and you can experience that in your own day-to-day life. That objects, even if you have to stop, you need a force. So when you study classical mechanics means phenomena which is happening in our day-to-day life, or even at larger scale, then those things make sense. Like they make a logical sense. The mathematics part becomes a bit difficult, that you have to do difficult mathematics, but without mathematics we cannot actually predict things. So mathematics is essential. But the underlying science can be appreciated with logic also, with intuition also. One of the good thing about scientific method is that it accepts the limitations of our intuition and our logic. We may think, or we think this is how universe should behave. But universe is under no obligation to behave in the way we want it to behave. So universe का behavior है वो बहुत ज़्यादा mysterious है, बहुत ज़्यादा complex है. Nature is much, much more complex than we can imagine or we can intuitively understand. But once you accept that limitation, that okay, there are limitations, our sensory organisms like our eyes and ears and our skin, they will fail when we try to understand nature at very fundamental scale. Once we understand that limitation, and once we are ready to accept it, then will be the scope to enhance further knowledge, because we understand mathematics really well. And once we understand that even if it does not make intuitive sense or logical sense, but can we develop a mathematics around it? And is that mathematics correctly predicting things? If the answer is yes, then it's a good theory. So scientific theory accepts limitations of human intuition, human logic, human sensory capability. And then it says that even though our sensory capabilities are limited, let's try to develop mathematics, some theory around it. That theory based on some abstract mathematics, mathematics which we cannot appreciate in our day-to-day life per se. But if that mathematics is making correct predictions, then that is a good theory. So quantum mechanics is one of those theories that it does not make intuitive sense quite often. There is one of the best physicists, Richard Feynman, had a very famous quote about quantum mechanics, that there are two types of people in this world. One who does not understand quantum mechanics, do not understand quantum mechanics, and the other who pretend to. So let's try to pretend to understand quantum mechanics, that what it actually is. All of that, so quantum mechanics essentially deals with nature when we try to analyze things at very smaller scale. At larger scale, like I throw a ball, how it is going to move, all of that it makes sense. Even movement of planets and stars makes sense, turns out. Some cases, some things does not make sense, but most of the things make sense, even when we look at very large object. But when we apply the same set of ideas to try to understand about atoms and molecules and nuclei and protons and electrons and neutrons, then those ideas completely fail us. Completely. Like, not at all they make any accurate prediction. It leads to so much of problem. It creates more problem rather than solving any of the existing problem. And all of that, and even by the way, when we look at objects which are at very cold temperature, so it's not just very small, but even very cold, that when objects become in the range of minus 150, minus 200, minus 250 degrees Celsius, then also things do not make sense. The normal laws of physics which we have studied, they seem to be not applicable when we try to understand nature at very smaller scale. I should also tell you that quantum mechanics is often thought that it is applicable to nature at smaller scale. That is also not accurate. Quantum mechanics is applicable at larger scale also. The only thing is that at larger scale, quantum mechanics simplifies to classical mechanics. And classical mechanics is easier to comprehend, easier to understand. Intuitively, we can appreciate it. So we do not have to do quantum mechanics at larger scale. But quantum mechanics is correct even when we try to analyze nature at smaller scale. It's just that we do not have to do that. So it's a more fundamental theory about working of the nature. And all of that started with, again, understanding of light, that what is light. I talked about in previous classes that how Newton thought light is particle, Huygens thought light is wave traveling in ether, no ether. Maxwell clarified that light is electromagnetic wave. But Maxwell का जो पूरा theory है, he gave that theory in about, I think, 1890s, like end of 19th century. And just next or 2-3 years later, a phenomena was discovered. And that phenomena was that some scientists, it was an accidental discovery. Some scientist who was doing something else, entirely something else. And he found out that he took some metal, let's say this is some metal, and some light fell on this metal, on some element. And immediately electron came out of it. So some light of some frequency, red light or blue light, it fell on this metal, and that led to electron. And that was measured, that the entire chamber becomes suddenly ionized. You have flow of electric current here. Remember, electric current is nothing but flow of charged particle. So you have suddenly electron moving in your chamber. because the moment you had light incident on certain type of element. So this was an accidental discovery. But then people try to understand this phenomena with help of light. So clearly it is happening because of light, that we know causality. That light is somehow giving energy to this electron which is bound by atom does not have enough energy that it can cross this atomic barrier. But suddenly some light came and electron gained enough energy. So clearly that electron is getting energy from light, and because of that it suddenly got out of this atomic bound. This phenomena is called photoelectric effect. Photo means light. Light is causing electricity, hence the word photoelectric effect. So photoelectric effect, when it was discovered, Maxwell theory already was well established that light is a wave. People thought that let's try to understand this phenomena with help of assuming light as a wave. The problem was that if light is a wave, it will take about 100 years for this light to continuously illuminate this element before it can deliver enough energy that this electron will come out. More than 100 years. And this process was happening instantaneously. It's almost like something is knocking out electron. That all of that energy was coming to electron and something immediately knocked out electron. Almost if light is behaving as a particle. And this was what was done by Einstein, by the way. So Einstein now gave a theory for which, by the way, he was given Nobel Prize in Physics. But this was the simplest thing he did in his life. Einstein gave a theory that light actually has a dual nature. Sometimes it acts as wave, but it also has a particle behavior, that it acts as particle also. So light has a dual nature. And there are a lot of reasons to accept this. Because people thought that if light is wave, and wave have intensity, wave जो energy carry करेंगे, it will be because of intensity. So हम एक काम करते हैं, let's, जैसे मान लो there is an element where electron came out because of blue light. But when they used red light, electron did not come out. Again, it's a random experiment. I'm giving a random example. Some element X, where blue light was incident, electron came out. But when the same experiment was done with red light, electron did not come out. People thought that maybe red light is not intense enough. They increased the intensity of red light. Still electron did not come out. And they decreased the intensity of blue light. They made blue light very, very dim, and still electron came out. So clearly it is not dependent upon intensity. Something else. And we do know that blue light has higher frequency compared to red light. So based on all of that information, Einstein gave this theory that light has a dual nature, that light acts as a particle, and it also acts as a wave. And we cannot distinguish between these two properties. It's not that we can, sometimes it is acting as particle, sometimes it is acting as a wave. All the time it is acting as both wave and particle. So that is the first counterintuition, that imagining something as both particle and wave, that is the first counterintuitive thing, that we cannot imagine it. We cannot actually visualize it. When we think of a particle, we think of a very localized particle. There is a place where this particle is traveling with some speed. When we think of a wave, some sort of vibration propagating into space and time. But Einstein is saying that light is both wave and particle. And even though this does not make intuitive sense, but this very well explained photoelectric effect, it predicted everything about photoelectric effect really, really well. Einstein was given Nobel Prize in Physics for that, I think in 1921. He gave this theory in 1905. But then there was a French scientist, his name was de Broglie, and de Broglie gave this theory that it is not just light. Everything has a dual behavior. That everything in this universe which we think of has a dual characteristic associated with it. Everything is both particle and wave. So it's not just light. And de Broglie also gave a mathematics of it. That for larger particles, that wave behavior can be neglected because जब आप इसका wavelength निकालोगे वो इतना कम होगा कि वो zero के पास होगा. तो बहुत large particle अगर हो, जैसे for example this mouse traveling into space, I can neglect its wave behavior. It's almost zero. But now do the same exercise for an electron. So अभी तक हमने क्या assume किया था electron को कि electron एक particle है. We assumed an atom to be a particle. We assumed an electron to be a particle. We assumed nucleus to be a particle, proton to be a particle. But de Broglie is saying that this is not accurate. It is a particle, but it also has a wave behavior. So it's not just light has a dual nature. Even all subatomic particles or even atoms and molecules, they have a wave behavior. And this wave behavior at very smaller scale cannot be ignored. So it's not just light has a dual nature, but everything has a dual nature. Now remember, this is a theory. How do we confirm this theory? Is it a correct theory? Is it an incorrect theory? So people set up a device. In the previous class, I talked about Young's double slit experiment. In Young's double slit experiment, I told you that you take a cardboard, make two slits here, allow light to fall on these two slits. The two light which will come out from these two slits, it is going to interfere. At some places, light will interfere constructively. The light will become brighter compared to that original light. At some other places, it will interfere destructively. It will become darker compared to, it will completely vanish. And this was done by, shown by Young, like in early 19th century itself. That confirmed that light is a wave. So interference, that is a wave behavior. So in 20th century, people thought that let's do the same experiment, but now with electron. That let's say this is an electron gun now. And that electron gun is firing electron on these two slits. If electron is a particle, then maybe we will find electron here, 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 at all of the places. I can find electron everywhere here. Right, if electron is a particle. But if it is a wave, then it should show the same pattern what light showed. That there should be some places where electron will be found, but some other place electron will not be found. Again, some place electron will be found, electron will not be found. So all the places where I have not brightened it, those are the places where electron is not found. Now there is no reason for a particle to simply abandon some places. That somehow when electron was fired, it showed the exactly same pattern as light showed. So electrons are interfering. At some places interference is constructive, at some other places interference is destructive. So that further confirmed that electron is actually behaving like a wave. And people have done this experiment 1,000 number of times at different part of the world, and all of the time it had shown exactly the same result, that there are places where electrons are found, there are places where electrons are not found. Almost as if electron is behaving like a wave. De Broglie was given Nobel Prize in physics for that. That he was right, that particles, they have both wave characteristic as well as particle characteristic. It's not just light. Then there was another scientist. His name was Heisenberg. He was a German scientist contemporary to Einstein. He gave altogether a very interesting theory. His theory was that at macro scale, for example, let's say, when I throw this mouse, and I know that how much force I applied when I threw this mouse, so how much velocity it started with, and I know the force of gravity, I can exactly predict at what point of time what will be its velocity and where it will be located into space. I can do that. That is what classical physics is all about. If I knows all the initial condition, if I know all the forces which are acting on a system, then I can with 100% accuracy predict that how this system is going to evolve. That this is a mouse, I threw it. How much force I applied, in which direction I threw this mouse, I already have that information. I also have that information about Earth's gravitational force. I have all the information about to predict this mouse, that where it will be after some time and how fast it will be moving after some point of time. I can know about both position and velocity with 100% certainty. Heisenberg says that you cannot do that for subatomic particles. For subatomic particles like electrons or protons or atoms or molecules, or atomic or molecules also, if you know the position, you cannot know the momentum. Momentum is mass times velocity, so basically velocity. That if I know the position, so for example, if I know where electron is located, if I know where is electron, then I do not know how fast it is moving. And if I know how fast it is moving, then I do not know where it is located. But that is not the interesting part. The interesting part of this theory is what Heisenberg says, that it's not because we do not have good instruments. आप दुनिया का best instrument लेके आओ. Nature does not want you to know the precise location and precise velocity simultaneously. It is the functioning of nature. It is a fundamental law of nature that there are certain properties which you cannot know with certainty, 100% certainty together. If you have 100% certainty in position, then you have infinite uncertainty in velocity. That if you know where electron is, you not at all can tell me that how fast it is moving. And if you know how fast it is moving, then you cannot actually tell me that where it is located. So principle of uncertainty जो है, this is not as such some theory which is talking about precision of measurement, that we cannot make precise measurement because we do not have good devices. It is saying that nature is imprecise. Nature does not want you to know the precise location and velocity together. You have some error, हमेशा कुछ ना कुछ error होगा. So this is a fundamental law. इसका कोई proof नहीं है और कोई exception नहीं है. This theory was given more than 100 years ago. And after that, people have experimented to show that this is wrong. And there has not been a single experiment in last 100 years which shows that Heisenberg principle of uncertainty is wrong. The moment it is proven wrong, the entire quantum mechanics will crumble down. Quantum mechanics का foundation है that there are certain parameters you cannot know for certainty together. If I know position with high accuracy, then automatically I do not know about velocity, and the vice versa is true. And it's as if nature does not want you to know that. This is a fundamental law of nature. Again, this is a counterintuitive thing to do. That why would nature behave like that? Like why would nature behave in a way that position and velocity, I cannot know it together? But this is how things are designed, if it is designed. This is how things are, that there are certain properties you cannot know of that together. So this principle is called principle of uncertainty. Based on all of that, there was a great scientist named Erwin Schrödinger. Erwin Schrödinger he put all of that together, and he developed the first mathematical equation to understand how a particle will behave, a quantum particle will behave, how it will evolve. तो आपने जैसे फॉर एग्जांपल क्लास 9th 10th में आपने न्यूमेरिकल सॉल्व किए होंगे फिजिक्स में, कि आपको कुछ इनिशियल फोर्स दिया, मास दिया, आपको वेलोसिटी निकालना, एक्सेलरेशन निकालना, सारी चीजें आपने करी हैं, राइट? तो हमने न्यूमेरिकल फिजिक्स में सॉल्व किए हैं, क्लास 9th 10th में, 11th 12th में भी किया है हमने, न्यूमेरिकल सॉल्व किया है. सो इवन व्हेन यू सॉल्व numericals in quantum mechanics, yes, this will be a mathematical numerical, but there will be a fundamental change. The answer which you are going to get will not be a deterministic answer. जैसे when I gave some force to this mouse and I 100% predicted that where it will be, how fast it will be moving. But in quantum mechanics, I will not be able to do that. If it is a quantum particle, if it is an electron, and I want to know where electron is, and if I solve Schrödinger equation, so the way to do is solving Schrödinger equation. I put the initial condition, I'm looking at how the system will evolve. It's again a mathematical problem. The same way we have solved numerical, here also you have to solve a numerical. But that numerical will not give you a deterministic answer. It will give you probabilistic answer. It will give you an answer that maybe electron is here, but maybe it is here also. Or maybe there are some other positions also which electron occupies. So in quantum mechanics, the first thing in quantum mechanics which you have to know here is that turns out nature is probabilistic at very smaller scale. At larger scale, nature is deterministic. that if I know all the initial condition, if I know all the forces, with 100% accuracy, I can predict how a system will evolve. But at fundamental scale, at very smaller scale, nature turns out to be probabilistic. That I can only now talk in terms of probabilities. That electron might be here, might be some other place also. You will think that this also is not counterintuitive. Probability तो हम ऐसे मैथ्स में भी पढ़ते हैं कि हमने सिक्के को उछाला, वो या तो हेड होगा, ना तो टेल होगा. तो श्रोडिंगर इज सेइंग कि इलेक्ट्रॉन चलो यहाँ पे है या यहाँ पे है. तो इसमें कोई ऐसे कुछ काउंटर इंट्यूटिव पार्ट नहीं है. काउंटर इंट्यूटिव पार्ट ये है that जब आप मेजर नहीं कर रहे हो तब कहाँ पे इलेक्ट्रॉन. सो व्हेन आई मेजर्ड इलेक्ट्रॉन, आई फाउंड इट एट हियर. जैसे मान लो दैट दीज आर द आई सॉल्व श्रोडिंगर इक्वेशन. श्रोडिंगर का मैथमेटिक्स है, मैंने सॉल्व किया. आफ्टर दैट आई फाउंड अ सोल्यूशन. दैट सोल्यूशन इज टेलिंग मी that this is one place where electron might be, this is another place electron might be, and let's say, for simplicity, let's assume that the probability is 50% and 50%. Now, as per law of probability, what it means here is that if I make this experiment 100 times, then there is a very good chance that 50 times I will find electron in this orbit and 50 times I will find in that orbit. But what if I am not making the measurement? And then I have to answer this question that where this electron is located. Schrodinger is saying that you can say that electron is at both of those places together with 50-50% probability. This we cannot comprehend, that a particle at two locations together with some probability, we cannot comprehend that. Our brain cannot comprehend that. But when you assume that electron was at both of those locations together, and then you develop your mathematics, you get correct predictions. When you assume that electron already was either at 1 or 2, and that is what you measured, 50% of the time electron was already at 1, 50% of the time it was already at 2, and then you measured. When you assume that, you get wrong predictions. But when you assume that electron was at both of these locations together, and then you do your mathematics and you get correct predictions, even though those predictions are probabilistic, but those probabilities turn out to be true. That if I do this experiment 1000 times, 500, I get that. So beforehand, I have no way of knowing that if electron is here or here. But once I make the measurement, then electron ka jo pura quantum property hai, that collapses. It starts behaving like a classical particle. I will only find at 1 or at 2. I will not find electron आधा आधा बटा हुआ दोनों जगह पे. I will find electron at only one place. But beforehand, I can never know where that electron is. Schrodinger had this thought experiment, which is called Schrodinger's cat. Schrodinger imagined or asked its audience to explain what is, by the way, this property is called superposition or quantum superposition. Quantum superposition means that some system, some particle can be more than two or more than two states together with different probability. And when you measure it, then you'll find only one of those. But when you are not measuring it, you'll have to say that that system is occupying all of those states simultaneously. To explain this, Schrodinger asked its audience that imagine a cat in a black box. That black box is connected to some gamma radiation mechanism. That gamma radiation mechanism allows a switch to be on and off, and that switch is connected to some poisoned gas. So if gamma radiation has occurred, then the switch will be on, which will release a poison into that black box, and that cat is going to die. But if gamma radiation has not occurred, then that switch will remain off. There is no poisoned gas. You have no way of knowing that when this gamma radiation has occurred. And somebody asks you that if this cat is dead or alive, then without opening the box, you can only say that it is both dead and alive together. You cannot say that it is either dead or alive. You can say that it is both dead and alive together. However, when you open the box, you find either a dead cat or an alive cat. But when you did not open the box and you have to answer this question, that what is the state of the cat, you'll have to say that it is both dead and alive together. That is what quantum superposition is. Again, it is a thought experiment. But that is how nature behaves at very smaller scale. That when I'm talking about electrons or protons or atoms or molecules or nuclei, then I will have to answer into those superpositions. I cannot answer that into certainty, that it is either this or that. I will have to say both of that simultaneously to be true. That is why in the starting I said that quantum mechanics does not make intuitive sense. That intuitively हम इसको sense नहीं कर सकते, हम इसको appreciate नहीं कर सकते. We have not evolved to think that a particle can exist at 2 or more than 2 locations together. But the thing is that it is not a particle. It is not a wave also, it is some combination of wave or particle together, and that can exist at 2 or more than 2 states together with different probability. This is what quantum mechanics is, that it allows you to appreciate nature at very smaller scale, how nature at very smaller scale behaves. I will repeat whatever I have said here. All of that started with understanding of light, that light is both particle and wave as per Einstein. Einstein also became one of the critique of quantum mechanics. Why he became a critique of, even though he was the one, like he started this. His theory that light has a dual nature in a way started this entire idea of quantum mechanics. But then he did not pursue it. He felt that there are some problems here. Turns out he was wrong. His problems, whatever he talked about, those problems were finally discarded by group of scientists, that Einstein के जो assumptions हैं वो गलत हैं. So in any case, even Einstein, the most genius person who has ever lived, he was proven to be wrong in assuming that quantum mechanics is not accurate. And quantum mechanics is accurate. It is one of the most successful branch of physics. Whatever predictions quantum mechanics has made, all of those predictions have come out to be true. So quantum mechanics is one of the most successful branches of physics. There is only one thing we cannot explain in quantum mechanics. And that part is one of the fundamental problem in quantum mechanics. But if you ignore that problem, the rest of everything falls into line. That when I made the measurement, why electron suddenly collapsed into a particle? It was into some superposition state, both locations, 3 locations, 100 locations together. But when I made the measurement, it was at only one location. Why did it happen? What did I do? When I made the measurement, what did I do? That suddenly nature became deterministic. It was probabilistic before, but the act of measurement made it deterministic, made it behave like a particle. This phenomena is called quantum collapse. We do not know why does it happen. And by the way, people have done experiments on it. Let me tell you more about this experiment. Again, going back to Young's double slit experiment, there are devices जिनका intensity इतना कम है that when they emit light, we can assume that in 1 kilometer there is only 1 photon. So there is a device which is a very dim light device, which emits 1 photon at a point of time. Mathematically, I know that in 1 kilometer there is only 1 photon. People use this device in Young's double slit experiment on those 2 slits. And even that 1 photon, when you allowed it to go for the entire night, it led to this interference pattern. That even that 1 photon has a wave, and that wave is interfering with itself, and it is causing destructive interference or constructive interference, that somewhere the photon concentration is brighter, somewhere it is darker. So people did this experiment with 1 photon also, and Young's double slit experiment has been proven to be correct, which basically tells you that light is a wave. People did that with an electron gun. Again, same thing. That an electron gun which only fires 1 electron at one point of time. And even then we find the same pattern. That electron at some places is simply absent. And that is only and only possible if electron is behaving like a wave. That why would a particle suddenly become absent from some point? So clearly some destructive interference is going on at those points. But then they made a change here. They kept a sensor here, a photo detector or an electron detector. In case of light, a photo detector. In case of electron, an electron detector. So if this photon has been fired and this photo detector tells you, which you have used on the first slit. And if this illuminates, it means that photon has passed from this slit. If it does not illuminate, you have fired from here. It does not illuminate, it means it has gone from this slit. Again, you do the same thing for electron. That electron has been fired. And if electron detector tells you that electron is traveling from here, then you know that it has traveled from here. If it does not brighten up, it means electron has traveled from here. The moment you measure it, all of this pattern gets lost. Nothing happens here. Now it starts behaving like a particle. You find electron everywhere, you find light everywhere. That just by measuring, I lost all of that quantum information, and suddenly that photon is behaving like a particle, that electron is behaving like a particle, just by measuring it. Why does it happen? We do not know that. That why does it happen that the act of measurement leads to collapse of quantum state? That is something which we do not have any good answer to. There are many theories here, but none of those theories have been proven to be accurate, and these are simply theories. But if you ignore this part, that why does quantum state collapses? Why does particle which was at 2 or more than 2 position together, why does it collapse? If you ignore that part, then quantum mechanics is a very, very successful branch. It predicts nature really, really well. It is one of the most successful branches of physics. And all of this understanding, by the way, this was a development in 20th century, the first 50 years. It took about 50 years for quantum mechanics to be established as a proper discipline. Now it is taught in colleges, in universities, but it took more than 50 years to be established it as a proper discipline. It is taught everywhere. But in 21st century, now that this understanding has improved further, people have started utilizing these properties of quantum superposition. There is another property called quantum entanglement, which I'm going to discuss. And these properties have applications now in making very powerful computers, in ensuring that your communication becomes better, or multiple other things. So that is what quantum technology is. Quantum technology essentially is applications of quantum mechanics in many branches of technology, starting with computing, जो सबसे popular है, सबसे famous है. Quantum computers are, if in future we develop a powerful quantum computer, then it will be many, many times more powerful than the fastest and the most powerful supercomputer of the world. So quantum computer, by definition, will be much, much more powerful than supercomputer. We haven't built one. We haven't built a quantum computer which is more powerful than supercomputer. In fact, we haven't built a quantum computer which can do any real life problem per se. Why we have not built one, I will come to that part also. But quantum computers theoretically are more powerful than the most powerful supercomputers of the world. So that is one of the branch of quantum technology which is very popular. Quantum communication allows you secure communication without this fear that maybe whatever data you are sending, that data will be hacked, the data will be made sensed by some eavesdropper for which this was not meant to. That is called quantum communication. Quantum sensors allow you to make accurate measurements. That is called quantum metrology. So there are many branches of quantum technology where a lot of work is happening all across the world. Many nations and many companies are betting big on quantum technology, including Government of India. And with that, Government of India announced that national mission on quantum technology a few years ago. And that is why I'm discussing this topic. Whatever I'm going to make you write here, that will be more than enough for prelims or mains examination. Write down just few things. पहले तो हम context discuss कर लेते हैं that why are we discussing this topic. Recently, Government of India announced national mission on quantum technology. National mission on quantum technology. National mission on quantum technology. To be implemented by DST, Department of Science and Technology. To be implemented by Department of Science and Technology. Department of Science and Technology. With a budget of about 8,000 crore rupees. With a budget of 8,000 crore rupees. Quantum technologies are based on, write down, quantum technologies are based on, quantum technologies are based on, quantum technologies are based on postulates of quantum mechanics, postulates of quantum mechanics, a branch of science postulates of quantum mechanics, a branch of science which aims to explain, branch of science which aims to explain nature at very smaller scale, nature at very smaller scale, such as atoms and subatomic particles, atoms and subatomic particles, or even very colder scale, even very colder scale. There are many domains of quantum technology. There are many domains of quantum technology. Quantum computing, quantum communication. So quantum key distribution, there is a question again about quantum key distribution. That is part of quantum communication. I'm going to discuss that, do not worry. Quantum metrology. It's not meteorology. Meteorology is weather prediction. Metrology is science of accurate measurement. That accurate measurement जो करने वाला जो पूरा branch of science है, that is called metrology. So any questions if you have from this topic you can ask. Sorry? Newton was wrong, yeah. Why are we studying what? Sorry, which law? But Newton was wrong in that, but gravity, even in gravity he was wrong, by the way. First of all, Newton gave a lot of things. He gave a lot of theories. In some theories he was proven to be wrong. Many of his theories have been modified. But even then, so gravity jo hai at this scale which you have studied, Newton was very much accurate. So Newton was wrong in light behavior. So when I said Newton was wrong, I did not say that he was wrong at every place. Newton discovered calculus, like Newton literally invented calculus, it's a branch of mathematics. So don't make such generalizations that Newton was wrong everywhere. Newton was simply wrong in when he talked about property of light. But beautiful thing about scientific method here is, which I said earlier, that we do not have to look at how great a person is or how beautiful his or her ideas are. We simply have to know that if those ideas can be confirmed, and if those ideas are leading to some correct predictions, and if those predictions turn out to be wrong, then the idea is wrong. We simply do not have to accept कि नहीं बहुत बड़े इंसान हैं, कैसे गलत हो सकते हैं. We do not do that in science. कोई बड़ा इंसान नहीं यहाँ पे. Right, so there are, yes, great minds, but even those great minds can make a lot of mistakes. Newton made mistakes. जो Einstein का theory है, Einstein made mistake. Almost all scientists have made mistake, and that's fine. That's totally fine. Any other question? Okay, that's a good question. So in this case, the question he's asking is that when light fell on the atom, did it simply go from lower energy to higher energy, or did it actually come out of the atom? In photoelectric effect, it came out of the atom. In photoelectric effect, but what you said, that also does happen. That is how light gets emanated. ये जो light है, light क्यों produce कर रहा है? जो LED है, ये क्यों कर रहा है? Clearly, when we are supplying electricity, that is leading to a lot of electrons going to higher energy. When they come back, they release light photon, which we see this light. But in photoelectric effect, electron came out of the atom. It's not that it only went to some higher energy state. Any other question? We talk about what type of force you are talking about? Schrodinger. Mhm. Again, he is right. No need to remember Schrodinger term. Schrodinger का नाम याद रखने की कोई जरूरत नहीं है. हाँ, anyways, question आपका क्या है? Not two electron, one electron in two states or more than two states, not two electron. Whenever I solve this problem, I did that for just, let's say, one atom or one, whatever, like hydrogen atom को हमने solve किया, helium को solve किया. So it was not two electron, it was one electron which has this various probabilities to exist simultaneously into different quantum states. Again, why, so it's not separation, that this, it's not two electron, it's one electron which exists simultaneously into different quantum state. That is what my maths is telling me. अब ये जो है कि how is it possible? We do not know. We simply do not know. That is what maths is telling us. And that maths leads to correct predictions. And scientific method relies a lot upon making correct predictions, rather than what we can imagine or what we cannot imagine. Our language is limited. Our brain is limited in terms of if it can imagine it or not. So that is why I started with this. That in science we have to accept that there are limitations to human imagination. But once we accept that limitation, that's a good thing, because it allows you to now inculcate more and more knowledge. Right? बोलते हैं ना, wisdom starts from knowing your, like what you do not know. What you do not know, that is where wisdom starts. So scientific method relies upon that, that we do not have to imagine that what does it mean that electron is at two locations together. But if we do mathematics like that, again it's an abstract mathematics, when we do it like that, and then we solve our problem, and that solution is leading to correct predictions. And even those predictions are probabilistic, but they're talking about correct probability. जैसे, I solved a Schrodinger equation, the earlier problem I told you. I found a quantum state 1 and 2 with 50%, 50%. So if my mathematical equation is giving me this solution, then if I do measurement, then I will not find some third state. I will find either 1 or 2 only. And 50% of the time I will find 1, 50% of the time I will find 2. So even though it is not a deterministic prediction, it is a probabilistic prediction, but those probabilities are correct. And that is why quantum mechanics is a very successful branch of science. Do not try to go into that like imagining things, like how do I imagine it? That will not help you a lot here. That will simply come, just, we have to accept this, that this is something which we cannot imagine, right? And once you accept this, and you, again, quantum mechanics को appreciate करने के लिए, you need to fundamentally know the maths of quantum mechanics, which is beyond the scope of this class. But once you accept this, then you enhance your knowledge. My focus is only and only to explaining technology and its various set of applications. I cannot brief out the whole of quantum mechanics, that is not possible. So at very colder scale, how quantum mechanics works, again, that is beyond the scope of this class, but I will give you some practical examples of how at very colder scale quantum mechanics behave. So I will be talking about the concept of superconductivity, and that is a very good example of application of quantum mechanics at very colder scale. Why here we read about electron in quantum technology? Because electron is already a fundamental part of atom. A lot of reasons. Electron can exist freely, can come out of the atom much more easily. Electrons can be produced as independent particle much more easily. That is why I focused upon a lot on electrons, but does not have to be electrons. It can be other subatomic particles also. Why are we reading this topic? Now that's a good question. So we are reading this topic because of two things. First, there is a national mission here on quantum technology. ऐसा नहीं है कि खाली दुनिया में कहीं और हो रहा है. ये भारत में भी हो रहा है. India is investing a lot into quantum technology. Second, once you become a bureaucrat, you will be charged for making public policy. So जैसे IAS officers feel superior to other services, कि हम IAS officer हैं. But when you go to talk to a scientist, and they are explaining quantum mission, and आप बिल्कुल blank out हो, आप रूम छोड़ के जाओगे, हंसेंगे आप पे, कौन किसको बना दिया, कौन है ये? So जिस तरीके से when you think that by becoming an officer, maybe you'll have to take orders from some political leader who is not that well read, and that may be problem for you. So think of some scientist who, again, they suffer from the same problem when they're talking to IAS officers, that इसको कौन बना दिया है, कहाँ से आ गया पढ़ के? So that is why we should know about these technologies. Even though you do not know the maths of it, but you appreciate what it is, and you know its possible applications, that in which areas it can be applied to. So we read about this topic because we want to become an aware aspirant, that we actually do know that what is happening in the field of technology all across the world, but even in India. How can electron be seen or extracted for experiments? Electron cannot be seen with our naked eyes, but that's the good thing. We do not have to simply rely upon our visual perspective, that only when I see, then I know it is there. Like, there are a lot of other things which will give you confirmation if electrons exist or not. Go back to again what I said earlier, that at atomic, subatomic level, do not for a moment think that आपका जो visual, जो eyes हैं, they will be of any help. Our eyes become blank the moment you go less than, let's say, 1 micron meter. Even 1 micron meter you cannot see, but less than that you clearly cannot see. So do not for a moment think that you can see an electron. But yes, there are a lot of devices which can intercept electron. They know electron, they know what charged particle does, what type of reactions they can do, what type of physical changes can they do, and we can make devices to measure electrons based on that. Let's take a break here. I will talk about quantum computer and its applications, then we will go to quantum communication. Give this heading quantum computing. I talked about quantum superposition, which essentially is a property that a particle or a system can exist in 2 or more than 2 states simultaneously. That property is called quantum superposition. But there is one more property we should know about. What is this? There is one more property we should know about. Give this heading quantum entanglement. Quantum entanglement is actually a problem which Einstein did not like at all. Einstein thought that quantum mechanics is not complete or not correct. Not complete will be a more appropriate response. So quantum entanglement is a phenomena where 2 or more than 2 particles, so let's say 2 electrons, separated by some distance r, they are correlated with each other in a way. But again, it can be any 2 particle. I am just taking electron as an example. And if they are correlated with each other in a way that if I make some change to this electron automatically changes. And this change happens instantaneously, no matter how far these 2 particles are located. This phenomena is called quantum entanglement, that I made change to only one, but the other automatically changed, and that change was instantaneous despite the distance. So think about this, that let's say I have 2 entangled electrons. Again, imagine a thought experiment, that I have two entangled electrons. One electron is kept on Earth, the other on a rocket ship is placed on Sun. Do not take this literally, it's a thought experiment. Other is placed on the Sun. What quantum entanglement is telling you, that if I make certain changes to electron here on Earth, the electron on Sun will change, but that change will be instantaneous change. Einstein thought this cannot be accurate, this cannot be true, because Einstein is known for giving a very famous theory of his called special theory of relativity. One of the consequences of special theory of relativity I have talked about in nuclear technology, E is equal to mc squared. But the entire special theory of relativity hinges upon a fundamental law of nature that nothing can travel with faster than speed of light. That no information, no particle can travel with faster than speed of light. Particles which have zero mass, they can only travel with speed of light, such as photon. Photon does not have any rest mass, so they can travel with speed of light. But apart from that, no other particle can travel with speed of light. No information can travel with speed of light. What quantum entanglement seems to tell us here, that somehow when I made change to this electron here, the other electron automatically changed. Instantaneous, that was an instantaneous change. So it is clearly traveling with more than speed of light. Einstein wrote a very famous paper against it. When Einstein has written a paper, people have to take notice of it. For many years, people thought about how to answer if he is right, if he is wrong. And finally, there was a great scientist named Bell. And Bell proved mathematically, and he also asked people that there is an experimental device which can be used to confirm it. But he mathematically proved that why Einstein is wrong, despite special theory of relativity. So he did not say that special theory of relativity is wrong. He simply said that they both can exist together. So it's not that some information is traveling here, that I made some change to this electron, and because of that some information traveled to the other electron. Bell suggested that these two electrons cannot be imagined to be two separate particles. They have a single quantum state which is describing both of that. It's like, imagine these two electrons, one having color red, again a random thought experiment, another green. I keep both of them here on Earth, and then without knowing the color, I kept one on the Sun, I opened the one on Earth, I see this is green, then I immediately know the other one will be red. So it's not that some information is passing here, it's simply that particles cannot be described independent of each other. These are entangled particles. So Einstein was proven wrong here in quantum entanglement. All of the problems he had, those problems were proven to be wrong, that he was inaccurate there. But quantum entanglement is real, quantum entanglement does happen. The last year Nobel Prize in Physics tha, that was given to some scientist who used Bell's theory, developed a device that can this Bell's theory be confirmed, and they were able to confirm that. And that has actually paved the way for all of these technologies which I'm going to discuss, such as quantum computing. And Nobel Prize Committee recognized that 2 years ago. 2022 Nobel Prize jo tha, that was given for quantum entanglement. Quantum entanglement can be thought of like this. जैसे मान लो कि आप aspirants हो 3-4 लोग हो. Let's say that you are entangled with each other. What it means is that one of you studied polity, सबको समझ में आ गया, right? दूसरे ने economy पढ़ा, सबको समझ में आ गया. So how things will, the preparation will become so fast that सबको सारे topic पढ़ने की जरूरत नहीं है. एक किसी ने पढ़ा, सबको समझ में आ गया. Can be problem also, कोई एक भूलेगा, सब भूल जाएंगे. So, but you get the idea that what this quantum entanglement, if you want to imagine it, that you can imagine it like this, that I made change to one, but all the other entangled particles, they automatically changed on your behalf. So when we use the word quantum computer, it is altogether a separate device. The only common word here is computer. The entire science of quantum computer is very different. When we use the word quantum computer, it essentially processes data into something called quantum bits or qubits. This is a normal computer hai, they process data into 0 and 1. I told you that 0 and 1 को represent करना बड़ा आसान है electric circuit में transistors के help से. Transistors can be switched on and switched off with a very small electric current. So even a small electric current where transistor is switched on, that can be represented with 1. and if it is switched off, that can be represented with 0. So 0 and 1 को represent करना electrical circuit में बहुत आसान है, and चाहे वो हमारा mobile phone हो, चाहे laptop हो, चाहे कोई super computer हो, all of them essentially are doing data processing into 0 and 1, or even data storage is being done in 0 and 1. A quantum computer does not use 0 and 1 separately. It uses 0 and 1 together simultaneously. So rather than using these binary units, इसी binary unit को shortcut में हम bit कहते हैं. So bit is shortcut of binary unit. So rather than using this binary unit, a quantum computer uses something called qubit. And qubit means quantum bit, which essentially means that it is both 0 and 1 together. Now how can we do that? That's a separate question. There are certain quantum properties which can be represented in a way that it can represent both 0 and 1 together. Designing them, using them into a circuit is much, much more complex. But there are properties which can represent both 0 and 1 together. I will not go into those properties, that is also beyond the scope of this class. But there are certain quantum properties which can represent both 0 and 1 together. We have to use these qubits, many of these qubits together. These qubits also are entangled with each other. So qubit in itself is in a superposition state, that it is not 0 or 1. It is both 0 and 1 with different probability. And many qubits are correlated with each other in a way that if I make change to one qubit, other qubits automatically change. So even if I do a mathematical operation on one qubit, all qubits are working on my behalf. All qubits are doing calculation on my behalf. That is a very powerful parallel calculation. So with help of quantum superposition and quantum entanglement, qubits can solve problem many, many times faster than a typical supercomputer. So essentially, the fundamental working of a quantum computer relies upon the phenomena of quantum superposition. That is what qubit is. It is a superposition of both 0 and 1 together, not them separately. But it also relies upon entanglement, which means that whatever qubit you use, you have many qubits in your quantum computer, and all of those qubits are correlated with each other in a way that you make change to one, and the other automatically change, and all of them are now doing calculation on your behalf. And by doing that, we can now do calculations much, much more faster than any computer, supercomputer we know of, theoretically. Practically, there are challenges. Often people use this spinning coin, which actually has not landed on the surface yet, to explain superposition. The same way Schrodinger did that with cat. So think of a coin which has been tossed in the air. Only when it lands on the hand or on the surface, it is either head or tail. But while it is in the air spinning, and I have to answer this question, that is it head or tail, you'll have to say that it can be either of that. It can be both of that together. Only when it lands, it is 0. Again, coin is not a quantum particle. It's simply a probabilistic thing which is happening. But to explain that what superposition is. But an electron literally can be thought of as like two particles, one particle occupying more than two states together. So while classical states are often represented with 0 and 1, which what normal computers are, in quantum computing we represent both 0 and 1 together. And right now, a typical quantum computer looks something like this. It's, by the way, जो पूरा design है, जो room है, जो color है, it's not that कि इसका PR बहुत strong है, जो इसको beautiful बनाने की कोशिश कर रहा है. Like literally, it has to be designed in this way. It is kept into a temperature in a room where temperature will be maintained very close to 0 Kelvin at about minus 270 degrees Celsius or even less than that. And this quantum computer does not have, by the way, a lot of qubits. It will have perhaps 50 or 100 qubits. And those qubits, as of now, are not equipped enough to solve real life problems. problems which we use to solve on even our day-to-day computer or even on supercomputers. So जो present quantum computers हैं, they are not at all capable enough to solve, forget about complicated problems, they can only solve simple problems. And even then, there will be some margin of error and we have to do something about it. And why does it happen? I will come to that part later. But theoretically, if I can design a quantum computer with few million qubits, the maximum which has been achieved right now is a quantum computer owned by IBM, which I think has about 1000 qubit, if I'm not mistaken. And they have done this, they unveiled this just last few months ago. Before that, again, IBM had the second most powerful quantum computer, which had like 450 qubits. Google has another powerful quantum computer, few hundred qubits. But for quantum computer to start solving problems which are of use to us, problems, and what type of problems, I will come to that part later. For that, we need millions of qubits, lakhs and millions of qubits, and nobody is even close to that. But if we come close to that, in next 4-5, I don't know how much time it is going to take. Maybe it will take 10-20 years. But if we come close to that, then that will be an entire revolution in the field of computing and cybersecurity because of the possible applications quantum computers can have. And I'm going to talk about those applications in detail. Write down a few things here in quantum computer. Because probability, yeah, so probability of studied in maths, even in probability we do take AND case, ऐसा नहीं कि खाली we only take OR case, we take AND case also. But probability helps you in understanding quantum mechanics. But quantum math, probability is a branch of maths where we are dealing with, let's say for example, even things which are happening in our daily life. Coin toss किया 10 बार 5 बार head आने का क्या probability है, things like that. Yeah, we can do that. So in quantum mechanics, when we explain quantum states, the fundamental property of a quantum state here is that an electron is at both of these locations together. Or not just two, it can be more than two here. And my entire point here was that it can be difficult to intuitively appreciate it. But quantum mechanics का जो पूरा maths है, वो इसी बात पे dependent है. That when I'm describing an electron or any other particle or any atom or any nucleus, when I'm describing them, in a quantum state, they occupy multiple states together with different probability. Hence, we have to use this AND, that this or this or this, all of that together. Write down a few things here in quantum computing. A quantum computer is type of device. Quantum computer is type of device that uses principles of quantum mechanics to perform calculations. That uses principles of quantum mechanics to perform calculations. Perform calculations. Unlike classical computers, classical computers which represent binary units 0 and 1, which represent binary units 0 and 1, इसी को बिट्स कहते हैं शॉर्टकट में, बाइनरी यूनिट 0 and 1, to store and process data, quantum computers use qubits or quantum bits. Quantum computers use qubits, QUBITS, qubits. ब्रैकेट में लिख लेना quantum bits. Qubit can exist in a superposition of states. A qubit can exist in a superposition of states. Superposition of states. That is It can be both 0 and 1 simultaneously. It can be both 0 and 1 simultaneously. It can be both 0 and 1 simultaneously. Many qubits in a quantum computer. Many qubits in a quantum computer can be correlated with each other. Many qubits in a quantum computer can be correlated with each other. That change on one qubit changes other. Change on one qubit changes other. Change on one qubit changes other. This is called quantum entanglement. This is called quantum entanglement. With help of quantum computers, or with help of qubits, entangled qubits, with help of entangled qubits, a quantum computer can solve complex calculations. Quantum computer can solve complex calculations exponentially faster than even supercomputers. Exponentially faster than even supercomputers. A quantum computer can solve complex problems exponentially faster than even supercomputers. But for that to occur, you need more and more qubits. And there are other problems which we have to take care of. I'm going to come to the problems part later. But why quantum computer? What is it in our day-to-day life which cannot be solved by normal computer or supercomputers that we need a quantum computer? That is a very important question. And quantum computers can have applications in many areas, very similar type of applications which we talked earlier. I'm only going to highlight two applications which are unique to quantum computing. And these two sets of applications cannot be done by even a classical supercomputer. Apart from that, whatever we have talked about, weather prediction, simulations, climate modeling, scientific research, financial trading, like वो भी एक बहुत famous application है supercomputer का. बहुत सारे जो hedge funds हैं, who manage like billions of dollars of fund, they actually have supercomputers at their disposal where they are analyzing all of the data on a stock exchange market, and based on that they're trying to predict that how Sensex or Nifty or whatever, Dow, how it is going to move in next 10 seconds, next 15 seconds. जैसे normal इंसान trade कैसे करता है? Normal इंसान पहले तो trade क्या ही करेगा? Invest करेगा. तो normal इंसान Reliance के जाके stock खरीदेगा. With this hope that Reliance is going to do good in business. I buy stock because Reliance will do good in business. My stock price will increase, my money will increase. That is what normal person does. जो बहुत powerful funds हैं, hedge funds जो हैं, they do lot of trading. And जैसे for example, you know about intraday trading, कि आपने दिन में खरीदा बेच दिया. But hedge funds, they do within seconds trading. Like they do trading of that next second में price movement क्या होगा. They try to predict that price action movement, and based on that they buy or sell, they go short or they buy a particular stock. So to analyze such a huge chunk of data, जैसे मान लो निफ्टी में, जो निफ्टी है सेंसेक्स है, बॉम्बे स्टॉक एक्सचेंज में सेंसेक्स है, जो पूरा स्टॉक मार्केट का इंडिकेटर है. So many people are buying so many stocks together, analyzing all of that data together, and making sense of how stock market is going to move, and then betting on it. If it is going to move higher, you buy it. If it is going to go lower, you sell it. So making a bet on it. But hedge funds, which have like billions of dollars at their disposal, they often use supercomputing facilities. Such type of trading is called algorithmic trading. That you deploy algorithms to predict how stock market is going to move. But we can use quantum computers also for that. Quantum computers will be very good at making predictions even in financial market. So whatever applications we have talked about earlier, those applications will be, again, quantum computers can also do that. I will repeat, there is not a single quantum computer right now which can do either of those which we just studied in supercomputing. I am assuming a future where a company has figured out how to like overcome all the challenges, and they have made a quantum computer of million qubit, and then all of those applications which we have talked about, quantum computer can do that. But there are two things which quantum computer can do with such high accuracy that supercomputer completely fails at that. It is not possible for a supercomputer to do those two things. The first is data decryption, and the second is molecular simulation. As I told you that supercomputers can do molecular simulation, but उनके limitations होंगे. Because जो molecular reactions हैं, जो भी atomic and molecular level पे जो change हो रहा है, that essentially is a quantum change. When electrons are rearranging themselves between atoms and molecule, that essentially is guided by quantum mechanics. Supercomputer may try to predict it, but often it will not be very good at prediction, because supercomputer का जो underlying science है, that is not quantum mechanics, that is classical mechanics. If you want to actually predict how molecules will behave, how atoms and molecules will behave, then design a quantum computer, because quantum computer का जो underlying science है, that is quantum mechanics. And the atomic and molecular changes, they follow quantum mechanics. So if you want to now make a new medicine, then a quantum computer will be better at doing that compared to a supercomputer. So that is one area where quantum computer clearly will be superior to the fastest supercomputer of the world, simply because supercomputers do not follow quantum mechanics. But quantum computer follows quantum mechanics, and those atomic and molecular changes, they follow quantum mechanics. And a quantum computer will be better at simulating those atomic and molecular changes. तो एक तो ये है जो I think बहुत obvious appreciate हम कर सकते हैं, that molecular simulation के लिए, atomic simulation के लिए, a quantum computer will be really good at what a supercomputer can do. But there is second thing, and that second thing actually led to a lot of interest in quantum computing. To appreciate that second thing, I should first explain how our data is secured. So let's talk about some aspects of cyber security. Let's take a detour here. Before I jump to quantum computing again, let's take a brief detour. And let me try to explain that when you go and store your credit card data on Amazon website, then you are not worried about that this credit card data will be stolen by some third party, some cyber criminal. You are hoping that Amazon has taken all of that security mechanism to ensure that your credit card data is secure. Or when you are sending some message on WhatsApp to somebody, then you are hoping that this message will not be hijacked by some hacker here, some eavesdropper here. That you are sending something to somebody, hey, good morning, that is what we do on WhatsApp. So we are sending good morning. You do not want other people to know that you are wishing good morning to somebody. आपने देखा होगा ना WhatsApp पे एक message आता है, this chat is end-to-end encrypted. So let me try to explain what is that end-to-end encryption is. How does it work? And then I will try to explain how quantum computing fits into all of that. Essentially, it applied some mathematical rule to encode your data. Just remember, I told you in the very first class of this entire discussion of this topic, that for communication to occur, we need to follow certain rules and certain protocols. Only then communication can happen. The rules and protocols we are following in our day-to-day life to communicate with each other, everybody knows that. Everybody understands Hindi, English, any type of language. But I want to, let's say even in day-to-day life, I want to convey some information to somebody, which a lot of people do not know. I am following some different type of coding mechanisms. As I talked about Morse code, that how I can tap my finger, I can try to convey some information. But even if you know Morse code, let's say मान लो that I'm trying to convey this some message, some A person is conveying message to B in Morse code. A person C who knows Morse code will be able to decipher what is being communicated here. Right, just say I remember I had a recent meeting of some of my college friends, and one of my friend was telling me, his wife was telling us that in her house, they have all the women folk, they have a secret language, and they deploy this language when a guest has overstayed. कि बहुत दिन तक अगर कोई रह गया है तो इसको कैसे टरकाना है, and they start talking into that secret language which only they can understand, right? And my friend was able to figure it out. Clearly he was overstaying, so he was able to figure it out, that what is that, like what do they mean when they use certain words. So in this case, what we are trying to do here is that we are changing some information with some other information. We are coding our data, and then the person who understands this system will be able to decode it, but the person who does not understand the system will not be able to decode it. You need to know what is that coding mechanism. If you do not know that, then you cannot decode what is being talked here. But one problem which in communication everybody faced, that whenever we try to code data, just now I am talking about digital data. Whenever I'm trying to use some mathematical problem to code information, then if coding is very difficult, decoding is also very difficult. But coding करने के लिए फिर आपका बहुत सारा computation requirement चला जाएगा, तब जाके decoding आपका बहुत मुश्किल होगा. That's not a good problem. If coding is easy, decoding is also very easy, right? Just for example, let's say that I have developed a coding mechanism where ABC is written as 149. And I ask you that how XYZ will be written into this coding mechanism. I'm very sure that many of you have already figured it out, what it is, right? Anyone? What is the coding mechanism I have deployed here? I've simply taken the position of alphabet and I have squared it, right? So A ka position 1 hai, B ka 2 hai, 3 hai, I have simply squared it. So I just have to take square of 24, 25 and 26. मान लो, if I had given 24 square, 25 square, 26 square together, and I had asked you that what does it mean in this coding mechanism, you immediately know the answer is XYZ. So the problem was simpler in one direction, and it was because of that also simpler in the other direction. By the way, UPSC इस type के question पूछती है. UPSC में इस type के जो coding वाले CSAT paper 2 में बहुत questions आएंगे, that they will write some alphabet into something, and you have to know what is that coding mechanism then and there, and you have to solve that. So if coding is simpler, decoding is also simpler. If coding is very difficult, then decoding becomes very difficult. But then coding करने के लिए बहुत सारा time लग जाएगा, बहुत सारा computational requirement होगा, right? Not a good system. So then some mathematicians found out that there are certain mathematical problems which are really, really easy in one direction, but they are really, really difficult in the other direction. That most of the problems are, if you do that in one direction, if it is easy, the other direction is also very easy. Whenever we apply ideas of mathematics in computer science, we use a word cryptography for it. So cryptography is essentially a branch of maths जैसे आप क्रिप्टो करेंसी पढ़ते हो, जो क्रिप्टो वर्ड है, क्रिप्टिक का मतलब होता है पजल. So cryptography is a branch of mathematics which aims to solve mathematical puzzle. There is a mathematical problem, you have to solve that. And that solution is rewarding. When you solve that, you basically get something else. There is some reward there. So when we apply ideas of cryptography, we do have, by the way, a lot of applications of cryptography in computer science. So certain mathematicians who are also good at computer science, they figured out that there are certain problems which are very, very easy in one direction, but very, very difficult in another direction. So to encode our data, let's use problem in the direction where it is easy. To decode that data, let's use the problem which is very difficult. So the best example, there are many problems, but I will give you the best example, which is the most popular coding mechanism. Take two very large numbers, prime numbers. So P and Q hai, these are two very large prime numbers. Very large ka matlab they have maybe 1 million digits, or thousands or lakhs or millions of digits, both P and Q. Multiply P and Q, even though there are million digits, this problem can be solved. This computer can solve it easily. It will take some time, But supercomputer can solve that like in a fraction of a second. Even if, let's say, P has 1 million digit, Q has 1 million digit, immediately a supercomputer knows that P and Q multiply karo, I get R. So this problem is easy in this direction. But the same problem becomes really difficult if R is given to you and you have to find its prime factor. That a very large number, a number of few million digits is given to you. And you need to know all of its prime factor. Remember, all number has unique combination of prime factor. ये तो पढ़ा हम सबने maths में. That हर prime number क्या होता है? जिसके दो factor है, either number 1 or number itself. So, give R, you have been given R, and you have to, and R is a very large number by the way, and you have to find out its prime factor. This problem is so difficult that you apply Frontier, the most powerful supercomputer, and that will also take few years to solve this problem. And for all practical purposes, your data is secure basically. So the method which we use in our day-to-day communication, such as WhatsApp or wherever we are using this mechanism called end-to-end encryption, that essentially deploys a technology which is called public key distribution. Let me explain this. A and B, they are trying to communicate some secret data. Often in computer science, the people use Alice and Bob. So I will use this. That there are two persons, Alice and Bob. And there is a third person, Eve. Eve is shortcut of eavesdropper. That Alice and Bob, they want to send some secret data to each other. But they know that Eve is trying to listen to this. Eve is trying to figure out what they're talking about here. So Alice and Bob, they have to establish a coding mechanism. They have to change this data in a way that Eve will not be able to make sense of. Even if Eve gets a hold of this data, Eve will not be able to make sense of what Alice and Bob are talking about. And they used that idea that some problems easy in one direction, some problems very difficult in another direction. What Alice will do, Alice has a public key, a key which can encode data. So Alice has a public key. That public key will be shared on a network. Let's say on internet, a public key encoding mechanism. That public key, for example, it's simply multiplying P into Q into R. This is my encryption key. That there is a mechanism where you solve this problem, and by solving this problem, you are encrypting that information. And Alice shares that on a public network. This information is available for everybody to see. Bob receives that public key, encodes that information, and sends that signal to Alice. But this can be now decoded with a private key. That private key is not shared anywhere. That private key is part of your specific device. Whatever the device is, your mobile phone, your laptop, whatever it is, that private key is part of your device. While public key is shared across network on all the server, private key only belongs to you. And this public and private key are not independent of each other. They very much are related to each other. So for example, this private key can be that a very large number is given, some x, very large number, and you have to find its prime factor. Since I already have that private key, I decoded that information really well. Think of this as a lock which has two keys. To open the lock, I used a key. To lock it, I used another key. So lock करना जो है वो आसान था, but वापस उसको open करना जो है वो बहुत ही ज़्यादा मुश्किल है. कि lock कोई भी कर देगा, but open करने के लिए I need a key, and that key is only available to, let's say, house owners. कि आपने घर छोड़ दिया, किसी को बोल दिया कि आप lock करके चले जाओ, and you know that locking is very easy, but unlocking only you can do. So a public key is shared on a public network. Using that key, Bob can encode the information. That encoded information will go to Alice. Alice already has the private key. Alice uses the private key and decodes that information. What will Eve do now? Eve found that encrypted information. Eve wants to decode it, but Eve does not have the private key. How does Eve find the private key? Eve has to solve a mathematical problem where x is given and you need to know its prime factor. Eve has a very powerful supercomputer at her disposal. Eve gave that problem to supercomputer Turns out that the supercomputer failed at this problem. It is not going to solve this problem even in matter of few hundred years. So for all practical purposes, Alice and Bob are assured of the fact that this data is not going to be stolen by anybody. That whatever communication they are doing, that is a secure communication. This technology is called public key distribution or public key infrastructure or public key cryptography. All of these mean the same thing. It is essentially is a technique to secure your data. And when you encrypt data, you know that this data cannot be decrypted because the underlying mathematical problem to decrypt that data, it's so difficult that you cannot solve that even with very powerful supercomputer. So think of now when I told you about my friend's story, that how some women have developed a coding language, and my friend just listening to it for some time was able to decode what they're talking. But what if this coding was much, much more difficult? And he has no idea that what is being talked here. An entirely different type of communication, which you cannot make sense of unless you give lot of time, lot of resources, spend lot of your brain, lot of time, and only then perhaps you'll be able to make sense of it. But in public key distribution, even with the best of the computing resource you have available, and still you are not able to decode the information. So this is how modern cybersecurity works. And this works for all type of communication, even for data storage. आपका जो credit card data store करके रखा है, that is locked by Amazon. और मान लो कि Amazon को कल पता चलता है कि there has been some leakage of data. But even then, this data is stored in encrypted form. And that decryption will be very, very difficult because it will require to solve a mathematical problem, which is very difficult. Now you also know that why when you make a profile on some portal and they ask you to give all of those combination. It may seem like a nuisance कि एक upper case हो, lower case हो, number हो, symbol हो, पता नहीं क्या क्या हो. Like बहुत सारी चीजें होती है ना कि जब भी आप password आपको बनाने के लिए कहा जाता है. The moment you keep adding different things, like a capital letter, small letter, a number, a special sign, some other thing. The moment you keep doing that, just for example, if your password is based on some dictionary का word, right? If it is 1 2 3 4 5 तब तो बिल्कुल ही खराब है. But even if it is based on some dictionary word और उसके आगे आपने 1 2 3 लगा रखा है, पूरा का पूरा ऑक्सफोर्ड डिक्शनरी एक सुपर कंप्यूटर को सर्च करने में 1/1 मिलियन सेकंड लगेगा. क्यों 1/1 मिलियन सेकंड में पूरा का पूरा डिक्शनरी देख लेगा. उसके बाद अब वो देखेगा कि आपने 1 2 3 लगाया गया सारे वर्ड्स पे. वो हर वर्ड पे पहले 1 लगाएगा, फिर 2 लगाएगा, फिर 3 लगाएगा, फिर 1 2 लगाएगा, 1 2 3 लगाएगा. इट मे सीम लाइक अ वेरी टीडियस टास्क फॉर यू टू डू दैट कि हम करके देखते हैं मैनुअली. बट फॉर अ सुपर कंप्यूटर इट्स अ वेरी फास्ट टास्क. बट द मोमेंट यू स्टार्ट एडिंग थिंग्स, that you start then the time taken keeps on increasing. And as you add all of those numbers and special symbols and everything, the time taken suddenly becomes पहले वो शुरुआत हुआ था 1 by 1 million seconds से, but it exponentially increases. It becomes years, thousands and millions of years, the moment you add all of those things together. That's a separate thing, but now you know that why in cybersecurity it makes a lot of sense to have a very strong password. Because there are cyber criminals, hackers, who are trying to guess your password all the time. And by doing that, they're trying to steal your personal information all the time. And you do not want to give them any leeway to that. Anyways, that's a separate topic. My topic here is public key distribution. So first, we should appreciate that how do we secure our data in modern communication infrastructure. We use this mathematical problem called public key distribution. You need to have computational capacity more than that. Like to hack a supercomputer, so supercomputer can have some vulnerability, and maybe you know the internal structure, you have good understanding of how it was deployed, you know of that vulnerability and you are trying to misuse it. So there are two ways. Either you apply brute force, it's like समझ लो कि आपको किसी को हराना है. तो हराना है तो एक तो तरीका ये है कि आप या तो खुद बहुत पावरफुल हो दूसरे इंसान से, तभी आप हरा सकते हो. बट आप पावरफुल नहीं हो. बट आपको जो पावरफुल इंसान है उसके कुछ वल्नरेबिलिटीज पता है. दैट मे बी ही इज वेरी वीक एट लेफ्ट नी एंड यू हैव टू अटैक दैट लेफ्ट नी ओनली. थिंग्स लाइक दैट. सो इन सच केसेस yes, there can be vulnerabilities even to supercomputing facilities. There are ways to do it. Either it will be brute force or utilizing some vulnerability which the system already has and people who designed it, they did not account for it, right? So and yes, it can be done. A lot of malwares which were deployed, they actually utilized that. Anyways, that's a separate question. There was a mathematician in 1997, his name was Shor, S-H-O-R. And Shor wrote an algorithm. It was a quantum algorithm. Shor imagined that in future there will be a quantum computer, and he wrote a quantum algorithm which can only be deployed on a quantum computer. And he showed that this problem where x is given, a very large number, and I need to find its prime factor, a quantum computer can solve that problem in matter of second. So what takes hundreds of years for a supercomputer to solve, a quantum computer can solve that in matter of second. So the entire cyber security which we talk about, as we think of that all of the data centers and banking infrastructure and finance companies and insurance companies or national security data, all of them deploy encryption technique. And those encryption technique essentially are dependent upon mathematical problems which are very, very difficult to solve, even with supercomputer. But with a quantum computer, those problems become very easy. So this was a theoretical calculation done by Shor that a quantum computer with few million qubits can solve this problem in matter of few seconds. And that led to a lot of interest in quantum computing. So ये एक opportunity भी है, but एक बहुत बड़ा threat भी है. And that is why there is a race going on right now all across the world that who is going to design the first powerful quantum computer of the world. And जिसके पास भी पहला होगा, that will actually cause havoc on the global market, because it can lead to decryption of lot of encrypted data. And that is also why lot of companies and countries are thinking about a world where quantum computers are reality. And you need to relook at cybersecurity, that how do we secure data when quantum computers have become reality. Turns out that the solution is also provided by quantum technology. And that is what quantum key distribution is. जैसे अभी थोड़ी देर पहले किसी ने क्वेश्चन पूछा था कि QKD न्यूज़ में था, वो क्या है, क्वांटम की डिस्ट्रीब्यूशन क्या है. I'm going to explain that. But public key distribution can be cracked by quantum computer. And that is a unique application of quantum computing, which is not possible even in case of supercomputer. So I told you that there are two unique applications we should know of. The first is molecular simulations, which can be done by quantum computer much better. Supercomputers do that, but there will be limitations. And the second will be decrypting encrypted data, particularly those encryption key which deploy public key distribution and mathematical problems which are right now you are assuming that they are very difficult to solve. But a quantum computer के लिए उतना ज़्यादा difficult नहीं होगा वो. And इसके अलावा जो बाकी के जितने भी applications हमने discuss किए, financial trading में, simulations में, all of those things, that it's there, that in quantum computer can be used for those applications also. So write down few things here. Applications, give this heading applications. First is breaking encryption. Breaking encryption. थोड़ा सा बैकग्राउंड पहले हम लिख लेते हैं. राइट डाउन मॉडर्न साइबर सिक्योरिटी. Modern cyber security relies upon mathematical problems or cryptographic problems, whatever you want to write, relies upon mathematical problems to encrypt data, These problems are difficult. For even a supercomputer to solve. For example, write down, for example, the most famous technique is public key distribution. Most famous key is public key distribution. This leads to, or this involves sharing of an encryption key, sharing of an encryption key that is publicly shared on a network, This key can be utilized by a sender to encrypt data. This key can be utilized by a sender to encrypt data. This key can be utilized by a sender to encrypt data. However, receiver has a private key stored locally. Receiver has a private key stored locally for decryption. If an eavesdropper is someone for which a communication is not intended for and still trying to listen to that. Metro में जो आप करते हो basically. So an eavesdropper if an eavesdropper wants to intercept the data, they have to solve a complex mathematical problem. Which even powerful supercomputers cannot. बाय द वे डिपेंड करता है कि कौन सी कंपनी है. अलग अलग कंपनीज का अपना खुद का साइबर सिक्योरिटी है. कुछ कंपनीज बिना इनक्रिप्ट करके चीजें स्टोर करके रखती हैं एंड दे आर मच मोर वल्नरेबल टू हैकिंग कंपेयर टू दोज हु हैव stored all of that information in encrypted form. Encryption requires spending a lot of money because even to encrypt data you need to invest a lot into computational resources. Write down, for example, finding prime factors of a very large number. 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 There is some problem in class, online? Only one student complaining right now. Any other online student facing problem in class right now? Working fine? Okay. आप अपना connection एक बार check करो. Anyways, so this is how modern cyber security works right now. Write down the next paragraph in the same point. A mathematician named Shor, the name is not important. A mathematician named Shor wrote a quantum algorithm which can exponentially which can exponentially factorize large numbers, which can exponentially factorize large numbers. So quantum computer can be used for decryption, and all of the encrypted data of the world in a way is threatened because of quantum computer. There is a flip side to it, that it can also be used to encrypt data in a way that even quantum computer cannot solve, and that is what quantum key distribution is. I'll come to that in quantum communication. But one more application you can write. Second application, quantum computers can do quantum simulations. Quantum computers can do quantum simulations. Quantum computers can do quantum simulations. Quantum simulations at atomic and molecular level. At atomic and molecular level. Molecular level. This has huge implications for making new materials, medicines, high temperature superconductors, high temperature superconductors, high temperature superconductors. इसके बारे में हम अलग से डिस्कस करेंगे. सुपर कंडक्टिविटी क्या है और जो हाई टेम्परेचर सुपर कंडक्टर का क्या मीनिंग है. विल हैव अ सेपरेट डिस्कशन अबाउट दिस. इसके अलावा जो बाकी के एप्लीकेशंस हैं, दे आर कॉमन. लाइक इवन विद सुपर कंप्यूटर, ऑल ऑफ द एप्लीकेशंस व्हिच वी हैव रिटन अर्लियर in optimization, in simulation, scientific research, all of those areas we can deploy quantum computer. But this has not happened. And by the way, there is a question here that any YouTube channel for quantum technology. Not a channel per se, but I can recommend that video, that channel which I was talking about earlier, that channel called Wired. And the same way, they had this video about explaining nanotechnology at 5 different levels of difficulty. They have this video about explaining quantum technology or quantum computing particularly at 5 levels of difficulty. I don't think higher level देखने की ज़रूरत, जो 5th level है वो बहुत ही मुश्किल होगा. But you can definitely watch that level 1, 2 and 3, and that will also make a lot of sense here to appreciate what is happening at the global scale. Give the heading challenges. यूपीएससी क्वेश्चन देखो कैसे पूछती है. Questions will not be very difficult. ये क्वेश्चन भी हम सॉल्व कर सकते हैं. In fact, I don't think this requires some special assist here. क्या होगा आंसर? All of the above. We are talking about again IoT devices, wearable device, IoT devices particularly, which can be used by human beings. So location identification, think of all the GPS receiver. Apple Watch is a GPS receiver, very good GPS receiver. Sleep monitoring, yes, it is possible. A lot of devices can monitor when you go to sleep, even patterns they can predict. And assisting the hearing impaired, ये बहुत पुराना है. Like this has been happening for quite some time. So all 3 is the correct answer. B is the correct answer, right? So, right, so questions will not be difficult, but इतने आसान क्वेश्चन अब नहीं आएंगे. अगर अब इस टॉपिक पे आएगा क्वेश्चन तो थोड़ा सा मुश्किल आएगा. 2 स्टेटमेंट का या 3 स्टेटमेंट का क्वेश्चन आएगा. इतना इजी नहीं आएगा that what does this word qubit mean here. But I do think this topic will remain in news even in coming times, right? So what are the challenges? The first challenge here is that somebody did ask this question. How do we design a qubit? Now, there are many ways to design a qubit. The problem is that we still do not know what is the best way. वो खुद में एक challenge तो है ही, but उससे बड़ा challenge ये है that qubits are very, very sensitive. जो quantum systems हैं, quantum systems in general are very sensitive. That if they suffer from any type of noise, जैसे I showed you that picture. This quantum computer has been kept in an isolated room at very, very low temperature. Even if somebody walks on the top of this room, which will cause some thermal vibration, and that will disturb those qubits, and those qubits will lose that information. So quantum systems are very sensitive. The moment they are exposed to external environment, even a slight fluctuation in temperature, some cosmic particle, you do not even account for it, some neutron which was traveling from some outer galaxy, came to outer atmosphere, entered in Earth also, and now is interacting with your quantum computer. That can disturb your qubit. Some minor fluctuation in pressure because somebody walked very fast there can cause problem. So qubits are very, very sensitive, and any type of changes, they lose that information, whatever information they are processing. This phenomena is called quantum decoherence. That qubits losing their information, there is a word for it, it is called quantum decoherence. Coherence means that qubit is able to contain that information for as long as possible. The best coherence time which has been achieved till now is few seconds. That the best of quantum computers in dunya mein, they can have that information stored without this fear of that they are losing this information for 5 to 6 seconds. So if you can solve your problem in those 5 to 6 seconds, then very good. If not, then whatever solution your qubit is giving you, there is a very good chance that it has a lot of error into it. So you cannot rely upon that solution because of quantum decoherence. So सबसे बड़ा problem ये है that qubits are very, very sensitive. पहले तो हमको पता भी नहीं कि what is the best way to design a qubit. There are multiple candidates. People are using superconducting qubits. People are using electron का जो spin angular moment. A lot of candidates are there. We do not know what is the best candidate right now. But the bigger challenge here is that no matter what the candidate is, all of them are very sensitive to external interference, and even a small change can alter their state, and we cannot simply rely upon whatever data, whatever answer they are providing us. This phenomena is called quantum decoherence. First problem. Second problem, that this problem further increases as the number of qubits increase. Abhi jo hai qubit hai 1000 qubits hai maximum. It starts becoming a good quantum computer when it has millions of qubits. But all those qubits are equally vulnerable. So as the number of qubits increase, ensuring that the quantum information is intact, that becomes a bigger and bigger challenge. So it makes quantum computer very expensive also. To operate quantum computer, we need to spend a lot of money. I don't think we will have a quantum computer in our pocket even 50 years down the line. It will be in some lab which can maintain all of such condition in a very specific domain. Right. So quantum computer is not going to replace the day-to-day devices we are using in our day-to-day life. But yes, it will be an addition. And how much time it will take, by the way, to solve these problems, that I think it will take at least 5-10 more years, or even more than that. But that's fine, because even the computer which we use right now, it took more than 50 years. The first computer designed in 1950s or 40s, this entire room was a hard drive which stored 10 megabyte of data. And now we can have a small memory card with like 1 terabyte of data. So that is possible. So it takes a lot of time first to overcome the hardware challenges, and then we look at other type of challenges. So पहला तो challenge यही है, that how to design qubit, how to ensure that they do not lose that information. Third challenge, that it is an entirely new branch of science. So you need skill set also. You need to be a very good computer scientist, very good mathematician, but also very good physicist now to actually deploy quantum technologies. We need an entirely new type of operating system. We need entirely new set of algorithms कोई भी जो प्रोग्रामिंग लैंग्वेज अभी तक आपने सीखा है, सी, जावा, पाइथन, वट एवर यू हैव लर्न, all of them are useless here because it essentially is a new type of science. We need to devise a new type of operating system, new type of programming language, and you need to learn that new skill. All that is also a challenge. तो आप लिख सकते हो, write down few things. First is decoherence. Decoherence. Write down. Qubits are extremely sensitive to their environments. Qubits are extremely sensitive to their environment. Heat, electromagnetic radiation, cosmic rays, can interfere with qubits, causing their quantum states to decohere. Decohere simply means that they lose that quantum information. Causing their quantum states to decohere. It's like goldfish. Goldfish loses its memory all the time. Does not remember what happened 5 seconds ago, which can be a great property, by the way. But goldfish, that it's like qubits are like goldfish, that they lose that information. Whatever information they carry, they lose it because they found some other particle, something interfered them, something blocked their view, or whatever, and they simply lost that information. Second, write down. For quantum computers to solve real life problems, we need lakhs and millions of qubits working together. However, as the number of qubits increase, their manipulation becomes difficult. In any case, इसी में एक लाइन और ऐड कर लेना. In any case, the most powerful quantum computer has hardly 1000 qubit, or has about 1000 qubit. The most powerful quantum computer as of now, in any case, the most powerful quantum computer has about 1000 qubit. Next, quantum computers kept to be in isolated room at very low temperature. Quantum computers are kept to be in isolated room at very low temperature, and very low का मतलब यहाँ पे cryogenic stage है, close to 0 Kelvin. Quantum computers are kept in an isolated room at very low temperature, which increases the cost, and maintaining such condition is very difficult. And the last point you can add here is quantum programming involves concepts that are fundamentally different from classical programming, We need new set of operating systems, languages, algorithms. We need new set of operating systems, languages, algorithms, skill set for quantum computing. जो हमारा ऑब्जेक्टिव है नेशनल क्वांटम टेक्नोलॉजी का, आई टोल्ड यू स्टार्टिंग में दैट वी हैव अ नेशनल मिशन ऑन क्वांटम टेक्नोलॉजी. उसका एक जो ऑब्जेक्टिव है दैट बाय 2031 let's have a quantum computer of 50, minimum 50, but maximum 1000 qubit. So we have given ourselves a very large range that may be 50 qubit, but hopefully also 1000 qubit quantum computer will be able to develop. I will complete this topic in next class, and then we will discuss AI, artificial intelligence, in detail. 2 more topics after this: AI, blockchain and cryptocurrency. So blockchain technology, that will be the last topic.